Hello once again, everybody. It is time for another stream. I apologize. I felt kind of like the doggy doo-doo lately, so the last few streams I just kind of didn't bother doing because I felt kind of like garbage. So I thought, hey, why bother streaming if I'm gonna feel like crap anyways? So yeah. So as the title implies, we need to start some stuff. If you're watching live, use bang TTS or exclamation point, whatever you want to call it, to be able to use Tib, and then you can do things like this. Oh, I just realized I didn't wire that properly. Ha 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 ha. It is not an Vulkan stream without something going wrong. That's not the right thing either. Excuse you. Properties. Yeah, you're not the right thing. Let's actually get the right thing here. Ha 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 ha. No, I don't want my iPhone monitoring. Thank you. There we are. Let's try this one more time. You can do something like...
User, Multibyte says, starting soon.
Hey! Okay, so there's that. So, now with all that said and done and diddle and whatever, don't worry about the TTS number. That's completely broken, so we're just going to ignore that for now. However, we're going to cover sort of two topics, and we will be rolling on from there. So we can kind of get an idea of what's happening, what's going on, and what's grooving. So, first things first. That last godot project, the one that I was working on, let me actually pull that up real quickly, because why the heck not? However, while I pull it up, I will mention this, is I think I'm going to sunset this project. And what are the reasons for me sunsetting it? Didn't I put a lot of effort into it? Wasn't I enjoying it? Kind of. So, here's the thing with this project. I don't hate it. But what my main issue was personally was that this was not a project that I necessarily wanted to do. I have this bad issue of getting carried away and sort of diving into something, getting kind of into it, and then like fixating on it. My main issue with this, though, is that this wasn't something I inherently signed up for. So I was kind of floundering, trying to figure out like, where do I want to take this? Where do I want to go? What do I want to do? And it kind of just led to wheels spinning, and just I didn't feel very good about it, right? So, I think as I mentioned, I don't hate this project, to be very clear. Like I'm not like upset with it, to be very clear. But it's also one of those things where in playing it, oh, I just realized I do not have the screen share going either. Ha 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 ha. Let's see, where is the window capture? There's the window capture. There it is. Whoop, there it is. Welcome to the game. Alright, well, good thing is that even this is broken now, so that's awesome. We'll try one more time. But anyways, on with what I was saying, is that this was a project that I kind of wasn't even that inherently into in the first place. It was kind of just the tutorial, and my intentions at the start were to actually just do the tutorial and move on. And then, I'm an idiot. So I got way too into it and stuck with it. Hey, Final Cut, go away. I don't care that you can't read that synth. Shoot. Now is not the time for you. Anyways, so little sippy. That is the first thing. The second thing is that from a programming standpoint, I have two sort of concerns personally. The first is that I don't feel like I'm getting enough low-level practice. Not because I necessarily hate high-level stuff. Ooh, that's a danger noise. I also just realized my speakers are on. Let me turn those off so I don't accidentally create a feedback loop that will blow everything's ears out in a 5-mile radius. Okay, there we are. Apologies. So, that's my second concern, is that I don't feel like I'm progressing enough as a programmer. And I feel like I'm kind of stagnating. That being said, I still think Godot is very valuable for learning design patterns, but I don't feel like I'm necessarily low level enough. So, what we will also be doing is, I had a small glance earlier, we will begin reading this. The C Reference Manual, 5th edition. I kind of clickbaited you by using the 2nd edition. Haha, no, we're doing the newer one. I just use the old one because it's a little bit more iconic. But yeah, so this is what we'll be kind of doing. And I have full intentions of chipping through this entire manual. This entire 500-page thing. I've read books similar to this. Like, I'm not afraid of reading. Also, one second, I'm just going to step away and turn this here because it is getting toasty in here. Beep, 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 beep. There we go. I think about 22 is a nice temperature. I think I had like 25 before. Whether that's Fahrenheit or Celsius, I will leave that for you to decide. Anywho, but yes, so that is currently a sort of place that I was in. And I just wasn't necessarily happy with it. So what I want to do is I'm also going to be going to school for computer sciences soon. So as a win-lose to me, I figured, hey, the course is going to be mostly in C, so why not slam this out? This came out 2 years after I was born, so hey, that's a neat thing, I guess. And then after going over this, if I have any issues with the C language, that's my fault. So yeah, that's nice and thrilling. So what my plan is as well is, let me let me hop over here. Let me go to Excalidraw. This was something I was referencing with somebody I was talking to in the DIMS. So my current plan to go forward is if you imagine this as the entire chunk of the stream, I'll just mark this out, like so. My plan is going to be this. So if the stream is approximately 4 hours, then we have some other fun stuff to do. So my first intent is to make roughly 2 hours of it, the whole C manual thing. Whoops, excuse you, you were supposed to type. Click. There we are. The C manual, approx 2 hours at a time, because I don't want to overwhelm myself. And then my plan from there is to spend the other approximately 2 hours doing game dev slash coding slash other. That's going to be effectively my plan for the future. And that being said, we'll still have fun streams on occasion. Like, there'll still be, you know, game streams. There'll still be, you know, streams that are kind of, you know, playing around and having fun and kind of doing whatever I want to. But I feel like doing the whole C manual thing would be a really good reference place to start. And I also feel like it would be a good sort of valuable thing, because then those of you who don't want to read, can't read, can then use it as a later reference and various other fun things like that. So that's where I'm leaning. I think that would be much more happy. Oh, yeah. And then what's the game dev slash coding thing we're going to be doing afterwards? So, because my intent was to do the 2D project and the 3D project, I'm going to stop the 2D project, then switch to the 3D project, and then after working on the 3D project for a while and doing that, getting that kind of done, then I'm going to transition to actually working on my own game. The 3D game project, I'm going to make 0 commitments to that. My intent is to do nothing serious with it. My only intent with the 3D project is to basically finish it to the point that it is advertised, and then that's effectively it. I want to do a tiny bit more with like exporting my own sprites with animation, so that way it's like I can get a sense of like what I'm doing, so that way I have a proper idea of the workflow. But outside that, that is effectively it. I also just realized I think that audio is playing, which it should not be. Ha ha ha, go away. So, with that being said, I don't have anything else bold to add to that. I don't think anybody here has anything bold to add to that. So what we'll be doing is we'll be transitioning forward, starting with the C manual for about 2 hours, give or take, until we reach a nice stopping point. And then, after that, we'll be transitioning into doing the more elucid, the more dangerous, the more death-defying stunt known as game development. So, with that being said, let's not jump in immediately, because I want to write down a timestamp for editing, because that makes my life a lot easier. Let's see. And let's see, what's the date today? It's the 18th. 10-18-2024. I'm doing it the other way, YMD, because YMD is the proper way, of course. Hello, Puppo. Oh, TRO. And then, I think this pupper might want something. Does this pupper need something, huh? Is something going on, Boo? What's going on with you? He got up and he's looking all concerned. I spent 2 days away from him because of like stuff. Oh yes, and that's another thing too, is that my IRL job is going to have me working out of town for about 2 weeks, starting on Monday, give or take. So my streams are going to be rather lackluster, and I won't be able to do an absolute ton. Production quality won't be as high, so that's going to be another small pain. So with that being said, you know, no shame, no salt to you know, any viewers or anything like that, but the production quality will be dipping for a bit, and then after I return, it'll be picking back up. Now, that being said, let me discover what this pupper wants, and then after I discover what this pupper wants, then we can start with the C reference manual. So, let's drag this down. Let's pull this thing up. You doing good, pupper? You doing okay? Are you doing alright? What's going on with you, huh? What's going on with you, huh? What's going on? Hmm? What's a pupper up to? What's a pupper up to, huh? What can I do for you? Are you hungry? Are you thirsty? You want some water? You want some water? Here, I think he might be thirsty, because he hasn't had water for a little bit. So let me go fetch the water, and then when I return, it will be time for us to start. Hello, Ari. Good luck with undefined behavior, Lamau. Yeah, I mean, I guess I'll define this real quickly. My intention, actually, with reading the C reference manual is not to become a C developer, as funny as that sounds. I actually personally don't see necessarily a ton of value with C. I would personally rather use a lot of C++, or I would rather use some dedicated shader language, like, you know, learn Vulkan. In fact, actually, if I can show it, this is a little thing that I'm planning to play around with later, all of this stuff here. The thing is, though, is that I want to, like I personally have always had this sort of lacking feeling that I'm kind of missing this piece of, like, programming by not understanding C and more low-level stuff. So my intent is to get good-ish with the low-level stuff, and then after I get the manual done, then I at least have a proper reference for how to use C, where to use it, why to use it, yada yada yada, and then I can take what I learned there and then move it forward elsewhere. Is it a perfect solution? Heck no. But what it is it is a solution that I can at least not rely on, but what's the term that I'm thinking of? That I can it will be a good basic. Oh no, undefined behavior is a thing in C++, C++, and the Vulkan API where certain instructions and behavior have unpredicted outcomes. Yeah, so I'm trying to think of how to, like, properly address that. So from my angle and what I know and what I have played around with C, because I'm not a complete C/C++ beginner. Like, I understand some basics of it, right? Like, I've done a good chunk of playing around, but I've never used a smart pointer. I've never used, like, malloc or the alternative to malloc, like free, and various things like that, right? So I have a very shallow understanding, right? And my understanding at that is very not basic. What am I thinking of? It's very hello worldy. Like, I've made some CLI stuff where I've taken some arguments and whatever. Like, a brief example is that, you know, like, what's a good example is, I don't know if I made a global reference to this or not, but, do I have it? Quadratic _ calculator. No, okay, I didn't make a bash reference for it. I didn't put it in my shell, but that's, like, an example of, like, one thing that I've done. Another one is, like, just, like, you know, factors _ of, and then, you know, what's the first number? Let's just do frickin' 15492. And then there you go, right? So, like, that's some stuff that I've done in C++. Like, I kind of understand some, like, basic looping and stuff with it, but I've never had, like, a serious project in it, right? Nothing to actually be good at it. So that's where this is coming in, is that I want to be good with C for the couple reasons that I mentioned before, and then hopefully go on from there. Because I forget what I was working on, but there's one thing that I was working on where it was... I ran into this really silly thing with C, where I think it was something where it's like... what was it? It was something like I couldn't define like an error value. It always had to be 0, but it was one of those things where like I didn't want 0 because 0 was a possible return, so it was basically impossible for me to decipher whether or not 0 was a valid or invalid value. And then basically just sitting there panicking, being like, well, I don't know how to deal with this. And the only thing that I can think of would be doing some like complex structure thing, which I didn't want to deal with. So that was awesome. Anywhoomst, I'm gonna go grab the water for the pupper real quickly, and then I'm gonna suffer through this thing for a little bit. So B to the R to the B, IE. There we go. Yeah. All right, I need to put on a jacket because it is pouring outside. Pouring outside. Pouring outside. Do you stay, baby? You stay. You stay.
Outside for 5 seconds and I'm wet.
Here you go, though, Pupper. Here you go. Here you go. Here you go. Big glug. Big glug. Big thirst. Here you are. Drink up, Pupper. Drink up, big Pupper.
What do you want? Here, get your wawa. Come in, get your wawa. I got you the wawa. I fought the storm just for you. I braved the storm just for you, wee little Pupper. Just for you, wee little Pupper. There's a wee little Pupper, man. There's a wee little Pupper.
Oh, he doesn't even want the water. How rude! How rude! You are so rude. So rude. Anyways, now that I've returned, let us begin to slam into the manual. Let's see, let me just write down the timestamp for this. There we are, okay. Oh, now he gets the water. How rude. Anyways, on to the manual. So, my intention is I'm going to read through these in chunks. I'm not going to be referencing chat until I reach, like, the end of a paragraph, basically. And we'll kind of just go from there. So, yeah, let me just make sure everything is proper. I'm going to leave the music on here for now, but I think in the YouTube version I will probably remove it. We'll kind of just vibe and see how it feels. So, with this very stupid decision I have decided to put myself through, let us begin. C, a reference manual, 5th edition, by Samuel P. Harbinson III and Guy L. Steely Jr. Let's see. This is the best-selling authoritative reference manual, provides a complete description of the C language, the runtime libraries, and the style of C programming that emphasizes correctness, portability, and maintainability. Describing the C language more clearly and in detail than any other book. Authors Samuel P. Harbinson III and Guy L. Steely Jr. provide, in a single manual, the Standard C 1999. The new revision of the C standard supports complex and Boolean types, variable length arrays, precise floating point programming, and new libraries and portabilities for internationalization. Standard C 1989, the version of C used by most of today's programmers. Traditional C, common practice before 1990, with millions of lines of code used every day. C++ compatible C, code that can be used as C or C++. The complete C runtime libraries for all C versions. I will point out that this was published all the way back in 2002, so this might not be the most up-to-date, because I think it'll be missing certain tools like CMake and a bunch of other stuff like that, which released like way after, to my knowledge. Let's see. Thoroughly revised and updated. This expanded 5th edition includes a complete description of the latest C standards, ISO-IEC 9899 1999, with its powerful language extensions and new libraries. New Visit the website www.ca reference manual. CA reference manual. Each one of those capitalized like new words. Contains source code for the longer examples in the book, expanded discussions and language issues, and the latest ISO-IEC language corrigenda. I think that's what that is. Corrigenda. And other C versions. See a reference manual 5th edition. Okay, yes, that's the inside cover. This is all publishing stuff, so I'll give credit to the authors and then we'll carry on. Vice President and Editorial Director, CES, Marcia Horton. Senior Acquisitions Editor, Petra J. Rector. Vice President and Director of Production and Manufacturing, ESM, David W. Riccardi. Executive Managing Editor, Viso Brian, Brenner Brian, or one or the other. Assistant Managing Editor, Camille Trencoste. I'm sorry, I'll be much better later. I'm terrible at names. Production Editor, Lakshmi. I'm going to actually butcher this. Ramanin? I am sorry. I'm trying to do these authors right because we were about to read this whole thing. Cover designer Bruce Kenslar. Manufacturing manager Trudy Prescotti. Manufacturing buyer Lisa Dockwell. Yeah. Okay. I think that is that. Cool. For Diana, Drew, and Mike Harbinson. Contents. List of tables. We're going to skip all this. What I will do is I will stop briefly on each one so that if you wish, you can pause and see what we'll be getting into. Because holy crap. So here's this one. Here's all this. Here's all this. And here's all these. And here's some more of this. That is right, we will be going over 500 pages of the C manual. So, yay to suffering. Oh my gosh. Okay, a couple blank pages. List of tables. That's a lot of tables. We're going to skip this. Okay, preface. This text reference manual for the C programming language, our aim is to provide a complete and precise discussion of the language, the runtime libraries, and the style of C program that emphasizes correctness, portability, and maintainability. We expect our readers to already understand basic programming concepts, and many will be experienced C programmers. In keeping with the reference format, we present the language in a bottom-up order. Lexical structure, preprocessor, declarations, types, expressions, statements, functions, and runtime libraries. We have included many cross-references in the text so that readers can begin at any point. The 5th edition now includes the complete description of the latest international C standard, ISO-IEC 9899 :1999, also referred to as C99. We have been careful to indicate which features of the language and libraries are new in C99 and point out how C99 differs from the previous standard C89. This is now the only book that this is now the only book that serves as a reference for all major versions of the C language, traditional C, the 1989 C standard, the 1995 amendment, and corrigenda to C89. And now we have the 1999 C standard. It also covers the clean C subject of standard C and standard C++, although here there is much new material in C99. I have not changed the chapter and section organization of the book significantly, so readers familiar with the previous editions will not have problems finding the information they need. The book originally grew out of work in Tartan Inc., developing the family of C compilers and a range of computers from micros to mainframes. We want the compilers to be well documented, provide precise and helpful error diagnostics, and generate exemplary, efficient, objective code. A C program that compiles correctly with one compiler must compile correctly under all other insofar as the hardware differences allow. This is going to be painful with my dyslexia. In 1984, despite C's popularity, we found that there was no description of C precise enough to guide us into designing new compilers. Similarly, no existing description was precise enough for our programming desk customers who would be using the compilers that analyze C programs more thoroughly than was custom at the time. In this text, we have been especially sensitive to the language features that affect programming clarity, objective code, efficiency, and portability of programs among different environments. Once again, a reference to the manual. We encourage readers to visit this book website, creferencemanual.com. We will post example code, expanded discussions, clarifications, and links to more C resources. I'm going to have one more little sippy. In preparing this 5th edition, I want to especially acknowledge the critical help I received from Rex Jeski, former chairman of NCITS J11, Annex Trucks of Helsinki, Finland, and Steve Adamczyk, founder of Edison Design Group. For assisting with the previous editions, I would like to thank... That is a lot of names. I apologize. I will hold this here for a second, and we will let all those be read, because we know how bad I did with the names before. Some of the original example programs in this book were inspired by algorithms appearing in the following works. Beeler, Michael, Gosper, R. William, and Schruppel, Richard Hackman, AI Memo, 239, Massachusetts Institution of Technology, Artificial Intelligence Laboratory, February 1972. Bentley, John Lewis, Writing Efficient Programs, Presses Hall, 1982. Bentley, John Lewis, Programming Perils, monthly column appearing in the Communications of the ACM beginning August 1983. Kerningham, Brian W., and Richie Dennis M., the C Programming Language, Prentice Hall, 1978. Knuth? Apologies. This is why I skipped that little previous long section. Donald E., The Art of Computer Programming, Volume 1 through C. Addison Wesley, 1968, 1969, 1973, and 1981. And lastly, Sedgwick Robert Algorithms, Addison Wesley, 1983. We are indebted to these authors for their good ideas. The use of I instead of we in this preference reflects the Guy Steely's work and prevented him from being an active contributor in recent editions. This text still reflects his clear and rigorous analysis of the pre-C programming language, but he cannot be held responsible for any new problems in this edition. The C, a reference manual, is now over 17 years old. To all of our readers, thank you. Part 1, the C programming language. Or sorry, the C language. Same thing. Part 1, Introduction. Dennis Ritchie designed the C language at Bell Laboratories in the early 1970s, and it is and its ancestry traced from ALGOL 60 1960 through Cambridge CPL 1963. Martin Richards' BCPL 1967, and Ken Thompson's B language 1970 at Bell Labs. Although C is a general-purpose programming language, it has traditionally been used for systems programming. In particular, the popular Unix operating system was originally written in C. C's popularity is due to many factors. It is small, efficient, yet powerful programming language with a rich runtime library. It provides precise control over the computer without a lot of hidden mechanisms. Since it has been standardized for over 10 years, programmers are comfortable with it. It is generally easy to write C programs that will be portable across different computing systems in different countries and different languages. Finally, there's a lot of legacy C code out there that is being modified and extended. Starting in the late 1990s, C's popularity began to be eclipsed by its big brother, C++. However, there's still a loyal following for the C language and continues to be popular with programmers that do not need the features of C++ or where the overhead of C++ is not welcome. I am sorry for this quick... Actually, no, we'll finish this sentence and I'll say my bit. CS will stood the test of time. It remains a language in which the experienced programmer can write quickly and well. Millions of lines of code testify to its usefulness. Yes, and what I just want to add as well is it's funny how C is considered a language with too much overhead. As we are commonly using, like, websites that ship down, like, multiple megabytes of, like, data per, like, load. Like here, as a quick example, let's just real quickly, if we just go to, I'm waiting for my keyboard to turn back on. Let's go to youtube.com. Whoops. youtube.com. And then real quickly, I know this is a side, I apologize, but this is just, actually, yeah, let's just do a simple Google search. That'll work. If we go here, if we go to network, let's see. Just for a simple Google search, we have committed... Yeah, we're doing multiple kilobytes per second, but let's check out YouTube now. Because I imagine this is going to be much worse. Oh, yeah. Oh, yeah. Look at all that delicious data. To be fair, that's actually a lot better than I was expecting. But it's also not exactly, you know, nothing either. Anyways, I'm actually curious because as far as I'm aware, all you need is like what is it like? What's the C++ compiler? Oh my god, I'm spacing. It's like GNU++. What is it? GPP. GPP compiler. Okay, so this is for Atom, but I just want to see, does it specify a size? G++ compiler size. Sorry, I just have to find this out myself. What is the size of a compiler? That's not what I was looking for. Yeah, so the entire G++ code size compiles to about... oh no, that's for something else. Never mind. Here, you know what we can do actually? Here, let's just do this. I'm being stupid. Which G++? User bin that. There we are. We will copy that. We will then go into the Finder. Let me just open this up. Boink, boink, boink. Okay, so according to Finder, the total size of the GNU++ compiler is 119 kilobytes. Man, people were picky back in the day. When people had standards. GCC and G++. Yeah. Sorry, thank you for the credit. I completely forgot for a second. Isn't there also like Clang++ and a few others? In fact, I think that I have that one installed actually. Which Clang++. Yep, I have that one too. So I want to take a little peek at that one too real quickly, just because I'm morbidly curious. Where did my Finder go? Finder! Here, boy. Doink, doink, doink. Okay, so now we have Clang++ in here. I just have to see. I'm sorry. I know this is a huge aside, but I am so morbidly curious what was considered overhead back in the day. I have C++ just there. Calendar, CD, Clang++. Okay. Get info. Ooh, 119 kilobytes again! Dang! Dang! Yeah, there are several C++ compilers like Clang and MSVC. Yeah, I've heard stuff like that. I also remember hearing that, like, from, like, the Primogen that you had to pay for, like, C compilers back in the day, which, like, makes complete sense, but also is, like... So, that's very neat. I don't know what to think about it. I feel very conflicted, but at the exact same time, it's like, hey... I will confess, I also don't really know the reason to choose one compiler over the other. My guess is you basically, at random, choose an obscure favorite, and then you only switch if you find an issue. You know, it's kind of like Subway. You find one sandwich that, like, you'd like, and then you basically just stick to that for the rest of your life. Anywho. Shall we carry on? Let's see. The evolution of C. At the time, he wrote the first edition of this book in 1984. The C language was widely, or sorry. The C language was widespread in use. Was in widespread use. Jesus. But there's no official standard or precise description of the language. I think I read this already. Yes, I have done that. I think I just missed this little part right here. We have strived to keep this book up to date with programmers so they can use it as a reference manual for all dialects of C they're likely to encounter. Traditional C. The original C language description is in the first edition of the book. The C programming language by Brian Kernigham and Dennis Ritchie, Preston's Hall, 1978, usually referred to as K&R. After the book was published, the language continued to evolve in small ways. Some features were added, and some were dropped. We refer to the consensus definition of C in the early 1980s traditional C. The dialect before the standardization process, of course... my gosh, I missed this period there, and it threw me way off, sorry. Of course, individual C vendors have their own extensions to traditional C too. Standard C, 1989. Realizing the standardization of the language would help, C became more widespread in commercial programming. The American National Standards Institute, ANSI, I'm going to probably say ANSI, formed a committee in 1982 and proposed a standard for C and its runtime libraries. That committee, X3J11, now NCITS J11, was chaired by Jim Brody and produced a standard formally adopted in 1989 as American National Standard X3.159-1989, or ANSI. I wonder why they chose that. Recognized that programming was an international activity. The International Standardization Group, created as ANSI was being created. ISO-IEC JTC-SC22-WG14 under PJ Podger turned to ANSI standard into an international standard. ISO-IEC 9899-1990, only making minor editorial changes. The ISO-IEC standard was therefore adopted by ANSI. The people then referred to this commonly simply as Standard C. Since the standard would eventually be changed, we refer to it as Standard C 1989 or simply C89. Some of the changes from traditional C to C89 included the addition of a truly standard library, new preprocessor commands and features, function prototypes, which lets you specify the argument types in a function declaration, some new keywords, including const, volatile, and signed, wide characters, wide strings, and multibyte characters. Ooh. Many smaller changes, clarifications due to conversation rules, declarations, and type checking. 1.1.3, Standard C, 1995. Oh my god, are you... Sorry, here. Let me let Tib do it.
User, Bubshalub says, oh my god, are you really doing this?
Yeah, actually it's worse than you thought, Bubs. Let me just highlight this so I can reference where I am. Whoops, right there. So what I did, Bubs, is I ended up finding a newer edition of the manual. The 5th edition, not the 2nd edition. And you know what the difference is? The difference is around almost double the pages. Don't you love to see it? So, unironically, I am reading the C manual. And the worst part is that my minor dyslexia with these very technical terms that are not very easy to read are making me fucking scream on the inside. what the fuck changes with C? Well, great thing you just asked, actually, because as it outlines right here, some of the changes from traditional C to C89, 89 is in 1989, included the addition of a truly standard library, a new preprocessor commands and features, functional prototypes, which lets you specify the argument types in a function declaration, some new keywords, including const, volatile, and sign, wide characters, wide strings, and multi-byte characters, many smaller changes and clarifications to conversation rules, declarations, and type checking. How do you update a rock? Rocks weren't made to think. Look at what we did. We made rocks think and then everything went wrong. Oh my gosh. Anywho, yes. And then, as you can see here, if you look at this sentence right here, I don't want to read it again because this was actual pain for me to read, but like this entire like paragraph section, like right there, holy crap, that was hard to read. It was just terrible. Okay, anyways, let us carry on, shall we? Let us suffer a bit more, shall we? I'll read your message once it comes through on Tib, assuming it isn't a TTS, and we will suffer further a little bit more. So, let's see.
User, Bubshalub says, we really be beating the USSR with this edition of C.
Yeah. Yeah, pretty much. So, this is where we're at. My intention with this is to become a C wizard. And more or less understand C thoroughly than probably a lot of other people do. And then go from there. So anyways, yes, we are only on page 4. And we are 44 minutes into the stream. Jesus Christ help me. I'll read this next message, but then I'm going to read to the next chapter because holy crap. Bro, reading the dictionary. Borderline, yes. Except for that, I actually think this is harder. Because there's so much word spaghetti with this and, like, abbreviations and stuff that it's like... I am tempted, like, right here where it says WG14, just to say WUG14. Anyways, let's carry on. As a normal part of maintaining the C standard, WG14 produced 2 technical corrigenda bug fixes and an amendment extension to C89. Taken together, these made a relatively modest change to the standard mostly used by new libraries. The result was what we call either C89 with Amendment 1 or C95. The changes to C89 included 3 new library headers, ISO 646.h, wctype.h, and wcar.h. Because it's car, fuck. WCare chair 14. Fuck, H. Shit. Okay, anyways, carry on. Several new tokens and macros as replacement for operators and punctuation. Characters not found... Oh, sorry. Several new tokens and macros used as replacement for operators and punctuation. Characters not found in some countries' character sets. Ha. Some new formatting codes for the printf-scanf family of functions, and a large number of new functions plus some types and constraints for multi-byte wide characters. Let us highlight that real quickly because we've just jumped to here. Oh, because I have the markdown tool selected, not the highlight tool selected. There we are. Let's see. God bless you. Unfortunately, I can't stick around because I have much more interesting things to do, like watch rocks erode in the desert. Yeah, that's understandable. Have a great day. ISO-IEC. Ike? I think I might say Ike. Here, wait, one second. Keyboard turn on. How to pronounce IEC. Ike. Okay, let's see. How do we say this? Come on. That is not... Oh. Okay, well, I'm gonna move on because IEC... I think I'll just say... I think I'm just gonna say Ike from now on, because Ike is just a lot easier to say. So from this point forward, if I say Ike, I mean IEC. Because holy crap, that's going to be painful for me to say over and over and over again. ISO-Ike standards must be reviewed and updated on a regular basis. In 1995, WG14 began to work on a more extensive reversion to the C standard, which was also completed and approved in 1999. The new standard, ISO-Ike 8999-1999, or C99, replaces the previous standard and all core agenda and amendments, and now has become the official standard of C. Vendors are updating their C compilers and libraries to conform to the new standard. C99 adds many new features to C89-95 language and libraries, including complex arithmetics, extensions to integer types, including longer standard types, variable length arrays, a Boolean type. Holy crap, they only had Booleans in town? Oh my god. Anyways. Better support for non-English character sets, better support for floating point types, including math functions for all types, C++ style comments. They didn't have comments at C99 is a much larger change than C95, since it includes changes to the language as well as extensions to the libraries. The C99 standard document is significantly larger than C89, the C89 document. However, the changes are in the spirit of C, and they do not change the fundamental nature of the language. I envy you. Reading the Vulkan 1.3 spec, trying to find which formats I am guaranteed to use, whose PDF is 5,500 pages. Let me look that up. I'm very curious. Vulkan... I don't know why I told that with a C. Vulkan 1.3 spec PDF. Let's test this. Let's test this. I feel like I have... Oh, it's only a light 1500. Oh my god. Oh my god. Is it actually 1500 or did it just get cut off? Okay, it actually seems to be 1500. Alright. Unless you're referring to multiple versions, Ari, that is thankfully less. Oh, you sent the link. How wonderful. Let us witness. I'm guessing it's in... Oh, you posted in general chat. Ouch. Oh, with all registered extensions. That might be the catch. That might be the catch. Okay, I want to take a peek at this. Spec with all registered extensions. Oh, that's a loading bar. Oh, that's a loading bar. Oh, that's a loading bar. Oh, that's a spicy. That is a heckin' spoos. Okay. What even are the registered extensions? What even are the registered extensions? Okay, so, some of these make sense, and then others are just like, what the hell? Ray traversal, video capabilities, optical flow. Hey, look, it's your section. Extending Vulkan, features, limits, additional capabilities, debugging. I think if I read this entire thing, I'd have like a 6-figure job comfortably. Anyways, you know what, fuck it, I want to download it just to see how big this PDF is. Let's go, yeah, let's just download it and just go hard. I just want to see how powerful this is. Show and Finder. Let's see. Get info. This PDF is thankfully only 19.8 megabytes. Teeny, you know? I will say there is a part of me that is morbidly tempted to read this. I don't know why. Oh, can I even scroll it? Oh, that's a tiny scroll bar. God. You know this was definitely like a thing where like multiple people have like worked on this, right? And this is like multiple like professionals like working on this. Yeah. Yeah. So just the contributors page is 3, 4, 5, 6, 7, 8. Yeah, almost 9 pages long. Yeah, that's fun. I realize YouTube chat blocks links, which is why you didn't see it initially. Yes, sorry. Okay. I need to add this in like the description under a standard or something, but it's just weird. YouTube chat blocks like so many weird things and I don't know why. It's awesome. I don't really want to switch to Twitch for various reasons. Like, I have seen many creators just claim that they've been blocked without prime reason. And then there's a bunch of things too where like the standards feel like a moving goalpost. So if they change the standard and you previously broke it, you're just banned now because cool. So I don't want to switch, but nearly every GPU vendor collaborated on this. Yes, I do believe I saw, I mean, actually right here, you can see ARM, NVIDIA, and Huawei for just a small list. There's Intel right here, a bunch of AMD. I will say, the only real reason why I'm tempted to read this is because as far as I'm aware, Vulkan is actually cross-platform, as in, like, every, what do you call it? Not every language, but, like, effectively every GPU, as far as I'm aware, supports Vulkan. It's quote-unquote the one true cross-platform, like, graphics API. So that is the main reason why I'd be tempted to read this. Oh wow, they even have Blizzard on here. I saw, okay, there's Epic, there's Unity, there's Samsung, Intel. I'm just curious who I can peek on this now. Qualcomm, yep, that makes sense. More Intel, independent. Man, imagine just being the fucking Chad who just drops in here because you're dicking around with Vulkan. You're like, ah, that's a bug. Let's see. Lucasfilm, that makes sense. Google, yep. Valve. More Epic, more Valve. Oculus. Yep, that is a lot of people. That is, in fact, people. That is inclusively what this is. This is certainly people. Oh, sorry, I just realized I missed that last message from you, Ari. Nearly every platform except macOS, which you must use Malt10 to work with Vulkan, as Apple computers support Metal. Yeah, but like Apple's kind of a fuck you anyways, as far as I'm aware. I think, doesn't Vulkan actually like obviously I'm not trying to like fight you on this. I just remember reading, does Vulkan work on Mac? Yeah, see, like this is what I know. Maybe it's something where it's like the basic functions of Vulkan are like really basic, and then like what actual Vulkan supports is like much more complicated or something, like it's more like fragmented as you go deeper. I really don't know. But yeah, we should probably get back to reading the C manual, shouldn't we? Okay, so we have now made it to this is the highlighter. Why is the highlighter not selected? Oh, that is selected. It's just very hard to read. Cool. But yeah, nah, like fuck Apple. Like just with the whole like metal thing. It's like, yeah, like I don't know why Apple wants to be proud independent computer, but yeah, it's fun. I meant just not natively. There are small differences you may need to watch out for, but not really anything to worry about, to be honest. Yeah, that's fair. I remember listening to, so fun fact is Noodle, if you're aware of them. who is it? Noodle, like, they made the whole, like interpolation video and stuff like that, and, like, Crunch and the Halo videos and whatnot. They actually have a podcast. It's, like, Final V3, I think is what, like, the channel's called. And I remember, I believe their name is Sam, the like, co-host. They're just like, yeah, I was trying to make a thing for, like, macOS because, like, I hate myself, and, like, I just got R drive error. And then I showed that to people who work on macOS. I was like, that shouldn't happen. So, as far as I'm aware, Mac is effectively a hellscape to program for, which is why if anything's on macOS is basically in a web browser are made directly by Apple. I've heard the Apple way is cool, but the issue is that the Apple way is the Apple way and nobody else wants to contribute to the Apple way. So, neat. Anyways, let's see. 1.1.5 standard C. Also, hello, Adam. I tried to skip forward on a live stream. Yeah, fun little fact for you, Adam, is if you don't actually wish to watch right now, that's fine. I actually do my best to kind of go in later to live streams and give, like, loose timestamps. They're not, like, amazing. Like, I'm not trying to, like, hardcore, like, timestamp it, but, like, if there's ever a stream that like, you're interested in a part of it, but not all of it, like, feel free to abuse that, because I try to do that for, like, anybody who wants to watch. Anywho, back to reading the whole thing. Oh, also, Adam, last time you were here, you questioned about Godot. If you jump to the start of the stream, I believe somewhere around the 4-minute mark, at like 4 minutes in, you should see something that's talking about my plans with Godot and stuff like that. I don't want to rehash it all, but it's a thing for you there if you want. No pressure, but there you go. Anyways, yes, 1.1.5 standard C++. C++, designed by Bjorn Straustrup, something like that, at AT&T and Bell Labs in the early 1980s, is now largely supplemented C for mainstream programming. Most C implementations are actually C++ implementations, giving programmers a choice of which language to use. C++ has itself been standardized as ISO-IC 14882, 1998, or standard C++. C++ includes many improvements over C that programmers need for large applications, including improved type checking and support for object-oriented programming. However, C++ is also one of the most complex programming languages, with many pitfalls for the unwary. Standard C++ is nearly, but not exactly, a superset of the standard C. Since the C and C++ standards were developed on different schedules, they could not adapt to each other in a coordinated way. Furthermore, C has kept itself distinct from C++. For example, there's been no attempt to adopt simplified versions of C++ class types. It is possible to write C code in the common subset of the standard C and C++ languages, called clean C by some, so that the code can be compiled as either C program or C++ program. Since C++ generally has stricter rules than standard C, clean C tends to be a good portable subject which to write. The major changes you must consider when writing clean C are: clean C programs must use function prototypes. Old-style declarations are not permitted in C++. Clean C programs must avoid using names that are reserved words in C++, like class and virtual. There are several other rules and differences, but they are less likely to cause problems in this book. We explain how to write standard C code so that it is acceptable it is acceptable to C++ compilers. We do not discuss features of C++ that are not available in standard C, which of course includes almost everything interesting in C++. But now I prefer to be here whilst live. I don't actually care about Godot that much. Lol. Fair enough. Yeah, you just asked about it. I guess the TLDR for you is basically that old 2D project I'm going to abandon because I just basically overcommitted to a tutorial for no reason. So I'm going to do the 3D tutorial, and then after I do the 3D tutorial, then I'm actually going to work on a project that I actually care about. B to C to C++ to C sharp. Yep, that's how programmers count. Like, you know, how, Valve, they can't pout. I cannot speak. Okay, carrying on, and yes, lol. Let's see. I'm just gonna highlight this because, yep. Did I highlight that? Okay, did. So we're at this one now. I'm leaving these little highlights as a little stamp for like, hey, I've been here. What's in this book? This book describes three major versions of C. Traditional C, C89, and C99. It calls out those features that were added in Amendment 1 to C89, and it describes clean C subset of C and C++. We also suggest how to write good C programs that are readable, portable, and maintainable. Officially, standard C is C99. However, we use the term standard C to refer to features and concepts of C89 that continue through C99. Features that only exist in C99 will be identified as such that programmers using C89 implementations can avoid them. So why are you reading about C? The sort of long story short is that a lot of what I have been doing has been garbage collected or memory managed, which is kind of the same thing, but they've been memory managed programming languages, which I don't hate. But the issue is that I have a lot of high level concepts of programming which I want to like sort of delve deeper into, right? So I don't want to be one of those like programmers who like, you know, is like, I know JavaScript and nothing else. And on top of that too, I have a somewhat firm opinion that you should basically just use a language like C if it's something that is like viable, instead of using something like higher level like C# as an example. Because I've always had this sort of mental idea of that, like if we go here, let's just disable these layers after I lock them. Dink doink. I've always had this sort of mental idea of that programming is as effectively as like, if you imagine this as like C, let's make you a little bit thicker, please. We like it thick with 3 C's. There we are. Anyways, but yeah, so if you imagine C there, and then you imagine like a higher, like a scripting language like JavaScript over here, and in the middle you have like a language like, you know, C#, right? The way that I have personally seen it is that there's kind of this like void of viability where it's like, okay, if I want to code something, if I care about performance, you know, like, and then here's also like Rust and like, you know, C++, right? And then over here is like JavaScript and like Python, whatever, right? My mentality has always been, it's like I'm either writing a like code to be just do something, or I'm writing code to be performant, and I don't really see much viability in the middle here. So I'm going to try to see after learning the language C if it's actually justified to have that belief of, oh, if you need to be performant, just write it in a low-level language, or if I'm just being a dense asshole who doesn't really feel that, or who doesn't actually believe that. And I'm just parroting stuff that I've heard. Long story short, Ari says, gotta go into design and code meeting with some of my other team members. Catch you all later. By the way, don't be afraid to ping if you got any weird C++ questions. Sounds awesome. Hope you have fun with your meeting. I want to generally keep questions to a minimum, honestly, until I get to a point that I can like interact with the language more, like because I don't want to like hear a statement, be like, oh, well, that's stupid, and then jump forward, right? But yeah, hey, have fun, Ari. Hopefully catch you later. If not, then hey, you do you, have fun, and see you around. But yeah, so that's kind of my mentality towards the whole thing. Let's see. I saw a message from Adam, and then I'll continue reading. Boom, bum, ba-dum, ba-dum. It's not that hard. Well, okay, to clarify my statement a little bit by like what I mean by like it's not that hard, is that it's like, my argument is to effectively say is the way that I see it is that to be like a good diverse programmer, you should know more than one language. You shouldn't be stuck to one language, right? So my sort of thing is that it's like, it's assuming Python with less syntax. I fail to see what you mean there. But carrying on is like what I basically mean is like these languages tend to have a really large emphasis on like what do you call it, on like libraries, right? So like whenever I've seen like Python be used, and I've played with Python myself, it's always been like, yeah, you know, import this dot do that, bam, and it's just done. Like it's so incredibly hands off and abstracted that you're just like, what? Like it's like how in like JavaScript it's like document dot get element by ID. It's like, I don't know how that's working. Sorry, I mean Whitespace doesn't matter. Yeah. And then on the other end, it's like, personally speaking, from how I have played with C++, is from what I have done with C++, I've never understood the sort of rant of like, oh, C-C++ is really hard and whatever. So what I'm trying to do is, I would say I know JavaScript to an okay amount. I wouldn't say I'm like a JavaScript wizard, but I mean, like, you know, like I have this whole code monitoring application here where like I'm getting messages through an API, I'm updating the DOM, you know, I got like some cute little stuff like this. You know, like it's not amazing, but long story short is like, you know, I can make a JavaScript app pretty okay, right? Like it's not amazing to be very clear. I'm not pretending that's like the hottest shit, but like you get the idea, right? And I've messed around with languages like C# and like GD script and things like it, with like game development, right? And some other kind of in-between stuff. And then my thing is that I've rarely dipped my toes into here. I've made some CLI stuff, right? But I've never gone that far into it to have like a firm opinion. I've tried to play with Rust. I've actually done a good amount of like the Rust by example. So I gotta go like github.com/Vulbyte. I actually have a repo here, which is, what is 1BRC? Oh yeah, I was gonna play with that. But it was, where was it? It was, it should be here. Rust by example. Yeah, I was chipping my way through here, and I've got like I've gotten a pretty good okay way through the example. You can see I tried to mark it somewhat well, but I just kind of wasn't getting it, so I kind of just abandoned it because I didn't want to stick with something that like I didn't like get right. So I want to switch from Rust to C first, because a lot of Rust stuff seemed like really abstract, and then come back to Rust later because I can understand the value of Rust, but from a beginner perspective who tried to go into Rust first, oof, it was very rough. I swear they're all cross-compatible. I don't know what you mean by that, Adam. I apologize. C just being a little lower level than C++ and C is, I don't know, I never tried it. Yeah, and that's kind of my thing, is that I want to find out, right? Like I've heard nightmare stories. I have heard people sing its praises. I don't know. I've played with it a bit, other than the syntax being stricter and like segfault sucking when you try to do something like that. I've never experienced anything that bad. So like I want to get like in the weeds with C and like really see like if it's intense. All the C's are cross compatible. Yes, to an asterisk. Here's actually a thing with C that I learned, which is very fun, is that the integer size actually changes depending on the platform. So for instance, if you made a program where you expect the integer length to be, say, 64 bits, because that's the type of systems that we're on, right? You know, maybe, you know, 61 with one, you know, counting for like, you know, the sign, right? Positive, negative, right? Plus, minus. That's all like totally valid. But the issue then is that you have this massive sort of issue where, depending on the platform, the type of integer will actually change. So you can compile for a different platform, and it'll change to like 16. And I think I've heard it goes as low as like 42, or like there's some odd ones like 42. Cause like, sure, Okay, my defense, I code assembly for fun, so literally any programming language is easier for me. Yeah, kind of. Like, I understand a lot of those things at like a glance, right? Like the like the assembly stuff. Like I understand a lot of it is, you know, you have like stuff in memory allocated. You basically read a memory block which tells you where to go. You look at that memory block, it tells you what to do, which is generally going to be like an add function, a multiplier, whatever the assembly program is. And then you basically take whatever you were supposed to do, you basically just send it towards that little module. That module does this magicalness and then pulls it out. Int long short byte bool, that's all I know. That's mostly it from what there is. There's also a float. Floats are basically disguised integers. If you want to know how an integer works, or I mean, not an integer, a float, I can explain it very quickly, but if not, then don't worry about it. But yeah, so there's that and a few other things, and like, I understand how those things work, like I was just saying, right? It's just a massive hodgepodge of like, what the hell, right? Like it's just a huge mess, and it just turns into a huge like, bleh. Oh yeah, I forgot it. Yeah. So there you go. So I'm assuming I don't need to explain it then. Hey, maybe I'll make a video about it in the future. Who knows? But yeah, you get the idea. But yeah, it's all a huge, fun, wonderful thing. I saw you sent one more message, so I'll read that, and I want to power through this next section real quickly. Let's see when the chat thing updates. I know how it works. It's floating point binary scientific notation. Yeah, kind of, basically. But yeah, so anyways, carrying on is we will just roll forward. And go on. Which dialect of C you use depends on the implementations of C you have available to you and how you want your code to be. Your choices are C99, the current version of the standard C. It has the latest features, but some implementations may not support it yet. That will change rapidly. We're also on C like 11 now, so that's fun. C89, the previous versions of standard C. Most recent C programs and most C implementations are based on this version of C, usually with Amendment 1 additions. Traditional C, now encountered mostly with maintaining older C programs. Clean C, compatible C++. C99 is generally upward compatible with C89, which is generally upward compatible with traditional C. Unfortunately, it is hard to write C code that is backwards compatible. Consider function prototypes. For example, they're optional in the standard C, forbidden in the traditional C, and required in C++. Fortunately, you can use the C preprocessor to alter your code depending on which implementation is being used, and even on whether your standard C includes Amendment 1 extensions. Therefore, your C programs can remain compatible with all dialects. We explain how to use the preprocessor to do this in Chapter 3. An example appears in section 3.9.1. If you're not limited by your compiler or an existence of body C code, you should definitely use standard C as your base language. Standard C compilers are now almost universally available. The Free Software Foundation's GNU C, GCC, is a free standard C implementation with many extensions. Yay! Okay, I have one little message to check real quickly on my phone. Let's see. Okay, there it was just a tiny little bloop. Carrying on. Let us mark the trail. Let's see. I've messed with the individual bits before. Yeah, bit stuff is fun. I've done some stuff where I've intentionally done a what do you call it? A access out of memory thing where I could just like start reading strings and stuff that was like out of like the program scope, which was neat. Slightly terrifying, but I've done it before. It was real fun to fight the compiler to let me do that. Let's see. An overview of C programming. We expect most of our readers to be familiar with programming in a high-level language such as C. Wow. That is a statement. Holy crap. But a quick overview of C programming may be helpful to some. A C program is composed of one or more source files or translation units. Each each of which contains some part of the entire C program. Typically, some number of external functions, common declarations, are often included into the header files, which are included into source files with a special hash include command, section 3.4. One external function must be named main, section 9.9. This function is where your program starts. A C compiler independently processes each source file and translates the C program text into instructions understood by the computer. The computer understands the C program and analyzes it for correctness. If the programmer has made an error the compiler can detect, then the compiler issues an error message. Otherwise, the output of the program is usually called object code or an object module. When all the source files are compiled, the object modules are given to a program called the linker. The linker resolves references between the modules, adds functions from the standard runtime library, and detects some programming errors, such as the failure to define a needed function. The linker is typically not specific to C. Each computer system has a standard linker that is used for programs written in many different languages. The linker produces a single executable program, which can then be invoked or run, although most computer programs go through these steps. They may appear different to the programmer in integrated environments such as Microsoft's Visual Studio. They may be completely hidden in this book. We are not concerned with the details of building C programs. Readers should consult their own computer systems and programming documentation. Huzzah! Let's see. Trust me, it's way higher level than C++. Try looking at the ASM file. Standard.cout-hello. It's a long list. I mean, C++ is higher level. Yeah, I mean, it's... How do I put it? It's... This is somewhere where I think there is a common vocabulary mix-up. That being the definition of high level, I think, is often... confined or denoted by like how the language is to write. I don't think that's a good example of it being like higher level. I think it's mostly just that C++ has functions that allow it to seem higher level, right? So what I mean by that is that it isn't a higher level language, it's just that there's been a lot of effort to make it feel higher level, in the same way that Rust is a low level language that feels semi-high level. When, like, as an example of something else, like, say, JavaScript, it's basically impossible for you to do low level stuff, right? I mean by how far it is from machine code. Yeah, that is valid. It's also difficult though because the subject matter is C. So I thought you were referring to C in reference to C++ and like saying that C is higher, and it's like kind of. Context, my dear boy. Let's see. Example, suppose we have a program to be named a program consisting of the two C source files hello C and startup.c. The file hello.c might contain these letters. Hashtag include, opening angled brackets, standard io.h, closing angled bracket, in a comment defines printf, void hello, argument void, opening curly brace, printf hello, new line, closing parenthesis, semicolon, curly bracket. Since hello C contains facilities, the function hello that would be used by other parts of our program, we created the header file hello.h to declare those facilities. It contains the line extern void hello void. File startup.c contains the main program, which simply calls the function hello. Include hello.h, int main, opening parenthesis, void, closing parenthesis, opening curly brace, hello, called as a function, opening closing parenthesis, return 0, closing parenthesis. On a Unix system, compiling, linking, and executing the program takes only 2 steps. cc-o, a program, hello.c, startup.c, a program. The first line compiles and links the 2 source files, adds any standard library functions needed, and and writes the executable program to the file a program. The second line then executes the program, which prints hello. Other non-Unix implementations may use different commands. Increasingly modern programming environments present an integrated graphical interface to the programmer. Building a C application such as an environment requires only selecting commands from a menu or linking the graphical button. Let's see. Most programming language allow you to write directly. Allow you to directly write assembly. I don't know how valid that is. I'm almost certain any garbage collected language wouldn't, with a few exceptions. I should believe my teacher and write all my Java programs in the Java Virtual Computers Assembly. I don't know if they'd actually let you do that. Write assembly in Java, because the entire thing is that it's like a garbage managed language, right? So if you wrote assembly, wouldn't that effectively break the entire program? Plus, your entire program has to run in the JVM. So if you wrote any actual assembly, that would be either the JVM passing the assembly code to the machine, which seems sketchy as hell, or it would instead be not actual assembly, but it would be assembly that is understood by the JVM. Let's see. Java native interface, color interface. In theory, the extension should be possible, though one can imagine Java compiler that targets specific platform will allow assembly escapes. Yeah. By the way, int main is because the assembly programs need an entry point. Most of the time, I use I_start. Yeah, I mean, most programs need an entry point. Without an entry point, they make very little sense. Because like, how else would you tell? How else would you tell your program to start? It's like telling somebody who's never made a cake before to make a cake, and it's like, well, what do I do first? Yeah. Yeah, I don't know. And then on top of that too, like, sorry, I'm just thinking about this because by inherently writing assembly, like, okay, so this is something I will also argue real quickly. Also, I meant on the virtual computer, not the actual computer. You gotta be specific, because I will argue you. Plus then what I was going to say too, and this is what I will argue deeply, is that by transitioning to like by using I'm going to refer to it as an escape hatch. By using an escape hatch to transcend from a high-level language to a low-level language, I'm going to make the argument that you are no longer writing the high-level language. You are actually just writing a low-level language, and then you're embedding that within a high-level language. The same sort of way that something like Python can embed C code. Like, you're not actually writing Python when you're writing C code. That's not how it goes, right? I should stop blabbering on. No, it's fine. It's just like it's just like there's like concepts, right? So it's like I don't mind discussing these things because it sort of like expands knowledge, right? But it's also fun. I also do not understand the context behind or basic because I talk fast, so I don't know which part you're referring to. Yay! Let's see. 1.4 conformance. C. Oh, I'm gonna see what you said first. You can type data, then type bytes. Yeah, I think like in JavaScript as an example, you can do bitwise operations, right? So like if I just go here for a quick second, I can do something like if I go to like the console as an example, I could do something like what is it? It's like var a is equal to, I don't know, let's just do 189. Var b is equal to 001. Let's just comment that. So we print A, if we print B, so we have both the values, right? Then I can do something like console dot log, and then I can do like A or B. And then you can see there I have like a bitwise operation that like technically does a minus function in to a degree, right? But like just because I can do like a bitwise operation in sorry, that was an XOR, I think. But anyways, like just because you can do bitwise operations, I wouldn't argue that that's low level, right? I mean, you can type data, then type bytes. Basic, the programming language. I meant in basic. Yeah, languages are fun and stuff. But yeah, like this is part of my argument here, because like, you know, this is all nice and fun. Console.log. I also want to make sure I'm thinking of the right thing. Like if I do A or B, yeah, that adds up more. Yeah. Anyways, let us blitzkrieg through this next chapter before we delve into more conversation, shall we? Let's see. Both C programs and C implementations can conform to the standard C. A C program is said. I just realized oh no, never mind. It's the wrong thing. Whoops. I saw all those little things over there. I'm like, what are you doing? All right. Anyways, let's see. Both C and C implementations can conform to a standard C. A C program is said to be strictly conforming to standard C if that program uses only the features of the language and library described in the standard. The program's operation must not depend on any aspect of the C language that the standard characterizes as unspecified, defined, or implemented defined. There are standard C test suites available from Perennial Inc. and Plumhall Inc. that establish the conformance of implementations to the standard. There are also two kinds of conforming implementations, hosted and freestanding. A C implementation that is said to be conforming hosted implementation if it accepts any strictly conforming language. A conforming freestanding implementation is one that accepts any strictly conforming program that uses no library facilities other than those provided in the header files, float.h, ISO 646.h, from C95, limits.h, standard arg.h, std.arg, standard bool.h, c99, standard def.h, define, and standard int.h, c99. Chapter 10 lists the contents of these header files. Freestanding conformance is meant to accommodate C implementations for embedded systems or targeting environments with minimal runtime support. For example, such as systems with no file system. A conforming program is one that is accepted by conforming implementation data. Thus, a conforming program can be dependent on some non-portable implementation confined features of the conforming implementation, whereas a strictly conforming program cannot depend on those features. And so is maximally portable. Conforming implementations may provide extensions that do not change the meaning of any strictly conforming program. This allows implementations to add library routines to define their own hashtag pragma directives, but not to introduce new reserved identifiers or change the operation of the standard library functions. Compiler vendors continue to provide non-conforming extensions to which their customers have grown accustomed. Compilers enable or disable these extensions with special switches. Now, time to read chat again for a second. Basic is actually quite low level now that I think about it. You can literally write bytes into part of the OS. Gone are the days of direct memory access. Yeah, more or less. Like, again, on C, I can do and I have done some very sketchy things, which I probably shouldn't, but thankfully, most, like on any main OS, almost any program is virtualized now, so that's neat. To prevent the whole OS from crashing when, things happen. So that's lay epic. But it's also one of those things where, it's... How do I put it? It's... From what I have experienced, most people have transitioned to a point of not wanting to actually code something for the act of computer sciences, but most people want to code out of the idea of getting a result, right? So like most people don't want to code something because, like, let's say it's fun. They want to code something because, they might be able to make six figures, or they might want to code something because they might be able to do, I don't know, they might be able to work from home, right? Like any various abstract idea. But the issue with that is sort of that it sort of reverts to and conforms to this idea of that if your motivations are that perverse, so to say, you're probably not going to have necessarily a good time with whatever it is you're trying to do. So that's very fun. Anyways, let us carry on. So we're on syntax notation now. This book makes use of a stylized notation expressing the form of a C program. When specifying the C language grammar, terminal symbols are printed in the fixed type are to be appeared in the program exactly as written. Non-terminal symbols are printed in the italic type. They're spelled beginning with a letter that can be followed by 0 or more letters, digits, or hyphens. Expression, argumentless, declarator. Semantic declarators are introduced by name of a non-terminal being defined followed by a colon. One or more alternatives then follow the succeeding lines. Character, put in character, escape character. When the words of one of the following when words of one of the this is a very weirdly written thing. When the words one of following a colon, this signifies that each type of the terminal symbols follow one or more lines as an alternative definition. Digit, one of, 0, 1, 2, 3, 4, 6, 7, 8, 9. Optional components of a definition are assigned by and appending the suffix opt to a terminal or non-terminal symbol. Enumeration constant definition, colon, enumeration constant, enumeration initializer, opt, initializer, colon, expression, opening curly bracket, initializer dash list, comma, opt, closing curly bracket. Let's see. Ooh, we're on to chapter 2. Chapter 2, baby, let's go. We're hitting big. We have slammed it. Anyways, lexical elements. This chapter describes the lexical structure of the C language, that is, the characters that may appear in the C source file, how they are collected into lexical units or tokens. Let's go like that. In fact, I'm just going to quickly skim back and just kind of highlight any chapters that I missed, because I just want to make it extra obvious for myself where I was and have been. Let's see, there's that. There's that. Whoops. Let's correct that. Excuse you. Can I undo you? Okay. We have done the introduction. Yeah, I guess I'll just leave all that blank, because yay. Huzzah! Okay, carrying on. So where are we at? So we were just up here. So lexical elements. Yes. Okay, yes. This chapter describes the lexical structure of the C language, that is, the characters that may appear in a C source file, and how they're collected into lexical units or tokens. 2.1 Character set. A C source file is a sequence of characters selected from the character set. C programs are written using the following characters defined in a basic Latin block, ISO-IC 1064-6. 1. The 52 Latin capital and small letters, A through Z. 2. The 10 digits, 0 through 9. The space, 3. The space. 4. The horizontal tab, vertical tab, and form feed, formerly abbreviated to HT, VT, and FF, control characters. And 5. The 29 graphic characters and their official names shown in Table 21. Yay. My news video won't stop growing in likes. The fun of YouTube algorithms. Yeah, as it goes. It's how it do. There's not really much you can do outside that. So, hey, nice. Good on ya. Let's see. Table 2-1 graphical characters. Exclamation mark, number sign, percent sign, circumflex accent, ampersand, asterisk, left parentheses, low line, aka underscore, right parentheses, hyphen dash minus, plus sign, equal signs, tilde, left square bracket, right square bracket, apostrophe, vertical line, reverse solidus, aka backslash, semicolon, colon, quotation mark, left curly bracket, right curly bracket, comma, full stop, aka period. less than sign greater than solidus / aka divide sign, and then the question mark. Wait, does C++ have the ternary operator? I forget what the ternary operator is, but I'm almost certain yes. Ternary operator. I mean, right there. Yep, it's apparently in C and C++. Though I will express, I fucking hate ternaries. Carrying on. I mean, okay, I guess I'll elaborate very quickly. I fucking hate ternaries because ternaries, in my opinion, are only really good for, like, if this condition is met, return. I think basically any other reason for a ternary is garbage. And I see way too many programs be like doing like nested ternaries and shit. And I'm just like, what the actual fuck is wrong with you? Anyways. Some countries have national character sets that do not include all graphical characters in Table 2-1. C89 and Amendment 1 define trigraphs and token respellings to allow C to be written as written in the ISO 646-1083 invariant code set. Additional characters are sometimes used in C programs, including formatting characters such as backspace and carriage return characters, and additional basic Latin characters, including the characters $, commercial at, and the grave accent. The formatting characters are treated as spaces and do not otherwise affect the source program. The additional graphic characters may only appear in comments, character constants, string constants, and file names. Reference basic Latin 2.9, character constants 2.7.3, comments 2.2, character encoding 2.1.3, character escape codes 2.7.6, execution character set 2.1.1, string constants 2.7.4, token respellings 2.4, trigraphs 2.1.4. Yeah. Let's see. You use nested ternary operators. I wish your program a very nice segfault. That's all. Let's see. Want a little sippy? Did my message not go through? No, it went through. I'm just trying to read in paragraph chunks. Unless it was the one after the ternary operators, then no. Probably not. You can monitor the chat like just above me there. If the message isn't seen there, I don't see it. So that's a pretty quick and dirty way to test the YouTube chat. Let's see. The character set interpreted during the execution of a C program is not necessarily the same as the one in which the C program is written. Characters in the execution character are represented by their equivalents in the source character or by special character escape sequences that begin with the / character. Okay. In addition, the standard characters mentioned before, the execution character set must also include a null character that must be encoded as the value 0, a new line character that is used as the end of line marker. Character set. 3, the alert, backspace, and character return characters, or carriage return characters. The null character is used to mark the end of strings. The new line character is used to divide character streams into lines during input-output. It must appear to the programmer as if the new line character were actually presented in the text streams in the execution environment. However, the runtime library implementations is free to simulate them. For instance, new lines could be converted to the end of record implementations on output, the end of record indentations. Indictions could be turned into new lines on input. As with the source character set, it is common for the execution character to be set to include the formatting characters backspace, horizontal tab, vertical tab, form feed, and carriage return. Special escape sequences are provided to represent the characters in the source program. These source and execution character sets are the same when a C program is compiled and executed on the same computer. However, occasionally programs that are cross-compiled, that is compiled on one computer, the host, and executed on another computer, the target, When compiling calculates the compile time value of a constant expression involving characters, it must use the target computer's encoding, not the more natural to the compiler writer source encoding. Let's see what you said now. Let me restate it again. It's compact if statements. Shut your furry mouth. Read in order, not newest first. Just did. See, you said it's compacted if statements. Yes. I mean, in the exact same way that a regex is just a compact tokenizer. Nobody likes regexes. If you are the one who uses regexes, everybody around you hates you. That's just the fact. Nobody will bother reading it. Nobody cares. They're just going to let it happen. And that's where you can insert so many exploits. Look at XZ. Or ZX or whatever it was. I think it's XZ. Anyways. Let's see. Whitespace and line termination. In C source programs, the blank space, end of line, vertical tab, form feed, and horizontal tab, if present, are known collectively as whitespace characters. Comments discussed next are also whitespace. These characters are ignored except for insofar as they are used to separate adjacent tokens or when they appear in character constants. String constants are hashtag include file names. Whitespace characters may be used to lay out a program, the C program in a way that is pleasing to the human reader. The end of line character or character sequence marks the end of the program. Lines are in some implementations. The formatting characters, character returns, form feed, and or vertical tab additionally terminates source lines that are called line break characters. Line termination is important for the recognition of the preprocessor control lines. The character following the line break character is considered to be the first character of the next line. If the first character is a line break character, then another empty line is terminated, and so forth. A source line can be continued into the next line by ending the first line with a reverse solidus or backslash character with the standard trigraph !!/. The backslash and end of line marker are removed to create longer logical source line. This convention has always been a valid preprocessor command lines. Has always been valid in preprocessor command lines within string constants where the most useful and portable. Word is the most useful and portable. Darn. Okay, I need a shake. Lol, never heard of it. That note. It was held too well. Why are you reading about the compiler syntax? I don't know. It's in the manual. I'm reading it start to finish. Why the fuck not? That's how we do. Yeah. I mean, I don't know. It's what is going on. So that is how we will do. Let's carry on. Example. Even if tokens may be split across lines in standard C, the two lines, if left parenthesis A equals B, right parenthesis X equals 1, semicolon, EL backslash SE X equals 2, colon, are equivalent to the single line if left parenthesis A equals B, right parenthesis X equals 1, semicolon, else X equals 2, semicolon. If an implementation treats any non-standard source characters as white space or line breaks, it should handle them exactly as it does blanks at the end of the character, blanks and end of line markers. Respectively, standard C suggests that an implementation do this would be by translating all such characters to a canonical representation as the first action would be when reading the source program. However, programmers should probably be aware of relying on this by, for example, expecting a backslash followed by a form feed to be eliminated. Most C implementations impose a limit on the maximum length of source lines to both before and after slicing continuous lines. C89 requires the implementations to permit logical sources of at least 509 characters. C99 allows 4,095 characters. References, character constants 2.7.3, preprocessor lexical conventions 3.2, source character sets 2.1.1, string constants 2.7.4. Whoops. I think I was just up one. Yes. Tokens 2.3, trigraphs 2.1.4. Numark. There we are. Alright, each character in a computer's execution character set will have some conventional encoding, that is, some numerical representation on the computer. This encoding is important because C converts the characters to integers, and the values of the integers are conventional encoding of all the characters. All the standard characters listed earlier must have a distinct non-negative integer encodings. A common C program error is to assume a particular encoding when encoding is in use when, in fact, another one loads. An example, the C expression Z minus A plus 1 computes to one or more of the difference of the encoding of Z and A might be expected to yield a number that the characters and the alphabet. Indeed, under the ASCII2 character set, results in is 26. However, under the EBCDIC encoding, in which the alphabet is not encoded consecutively, the result is 41. Bullet. I'm gonna let Tib read this one. I need a small break.
User, Bubshalub says, I watched a review of the new Tesla Model X and this dude was complaining that autopilot caps at 85 miles per hour, 135 kmph, and he usually does the drive at 90 miles per hour, 145 kilometers per hour.
I'm sorry, I don't trust autopilot in a fucking open field. I have no fucking idea how any dude would trust it at, like, actual race car speeds. That's kind of fucking insane. Also, hey, Bubs, congratulations. You were chat number 69. Congratulations, you little firework. Pew! Let's carry on. Oh, we just read that part. We're on Trigraphs now. A set of trigraphs is included with the standard C, so that C programs may be written using only ISO 646-1083 invariant code set, a subset of the 7-bit ASCII to encode set and code set that is common to many non-English national character sets. The trigraphs introduced by two consecutive question mark characters. Listen table 2-2, standard C also provides for respelling of some tokens, section 2.4. And header ISO 646.h defines macro alternatives for some operators. Unlike trigraphs, those alternatives will not be recognized in string and character constants. Trigraph question mark left parenthesis replaces left square bracket, question mark left angled bracket replaces right curly bracket, question mark forward slash replaces backslash, question mark I believe that's a grave, replaces the arise thing, whatever that one is. Question mark equals replaces hash. Question mark right parenthesis replaces right square bracket, question mark right angle bracket replaces right curly bracket, question mark bang replaces vertical slash, question mark dash replaces tilde. The translation of trigraphs in the source program occurs before lexical analysis, tokenization, and before the recognition of escape characters in a string and character constants. Only these exact 9 trigraphs are recognized. All other character sequence, e.g., question mark, ampersand, are left untranslated. A new character escape, question mark, is available to prevent the interpretation of trigraph-like character sequences. Example. If you want a string to contain a 3-character sequence that would ordinarily be interpreted as a trigraph, you must use the / escape to quote at least one of the trigraph characters. Therefore, the string constant what question mark backslash question mark apostrophe actually represents a string containing the characters what question mark apostrophe. To write a string constant containing a single backslash character, you must write 2 consecutive backslashes. The first quotes the second. Then each of the backslashes can be translated to the trigraph equivalent. Therefore, the string constant question mark forward slash question mark forward slash represents a string containing the single character backslash. References: character set 2.1, escape characters 2.7.5, ISO 646.h and 11.9, string concatenation 2.7.4, string token respellings 2.4. Also, I will let Tib say the elegant expression that is to be expressed here at the current.
User Atom1 Creeper says, ah.
Well said. Let's carry on, I guess. So, from here, we're carrying on. Multibyte and wide characters. That's where we're at, right? Yeah. Multibyte and wide characters. Let me highlight this so we know where we're at. To accommodate non-English alphabets that may contain a large number of characters, standard C introduces a wide characters to wide strings. To represent wide characters and strings in the external byte-oriented world, the concept of multibyte characters introduced in Amendment 1 to C89, expanding the faculties for dealing with wide and multibyte characters. Wide characters and strings. A wide character is a binary representation of an element of an extended character set. It has an integer type wchar underscore t, which is declared in the header file standard def.h. Amendment 1 to C89 added the integer type wint underscore t, which must be able to represent all values of the type wchar underscore t, plus the additional distinguished non-wide character value denoted weof. Standard C does not simplify any encoding for wide characters, but the 0 value is reserved as a null wide character. Wide character constants can be specified with an additional constant syntax, section 2.7.3. Example: it's typical for a wide character to occupy 16 bits, so wchar underscore t could be represented as short or unassigned short on a 32-bit computer. If wchar underscore t were short and the value -1 were not a valid wide character, then wint underscore t would be short and weof would be -1. However, it is more typical for wint underscore t to be int or unassigned int. If an implementer chooses to not support an external character set, which is common in the US, C vendors, when wchar underscore t can be defined as char, and the extended character set is the same as the normal character set. Yeah. A wide string that is a continuous sequence of wide characters encoding with a null wide character. The null wide character is the wide character whose representation is 0 other than the null wide character and the existence of weof standard. weof. Standard C does not specify the encoding of the standard character set. Wide string constants can be simplified with special string constants, section 2.7.4. Multibyte characters. Wide characters may be manipulated as units within a C program, but most external media, e.g. files, in the C source program are based on byte-sized characters. Programmers experienced with the extended characters sets also have devised multibyte encoding, which are local specific map between the sequence of byte characters and the sequence of multi-wide characters. A multibyte character is the representation of a wide character in either the source or execution character set. There may be a different encoding for each. A multibyte string is therefore a normal C string, but whose characters can be interpreted as a series of multibyte characters. The form of multibyte characters and the mapping between the multibyte characters and the Y strings implementation is defined. This mapping is performed for wide character and wide string constants at compile time. And the standard library provides functions that perform mapping at runtime. Multibyte characters use a state-independent coding, in which the interpretation of multibyte characters may depend on the occurrence of previous multibyte characters. Typically, such an encoding make use of the shift characters. Control characters that are part of the multibyte character and that alter the interpretation of the current and subsequent characters. The current interpretation within a sequence of multibyte characters is called a conversion state or shift state of encoding. There is always a distinguished intentional conversion shift state that is used when starting a conversion sequence of multibyte characters that is frequently returned to at the end of a conversion. Got my brain going all splurby. Example. Oop. One small thing I just need to adjust. Doop-a-doop. Okay. There we are. Encoding a hypothetical encoding that we use in examples is state dependent with two shift states up and down. The character up changes the shift state to up, and the character down arrow changes it to down. In the down state, which is the initial state, all non-shift characters have normal interpretation. In the up state, each multibyte character consists of a pair of alphanumerical characters that define a wide character in a manner that we do not specify. The following sequences of characters each contain 3 multibyte characters under encoding A, beginning the international shift state. ABC, AB up arrow E3, up AB, down B, up 2, 3, and then finally down A, down B, down C. The last string includes shift characters that are not strictly necessary. If redundant shift sequences are permitted, multibyte characters may become arbitrarily long, e.g. down, down, dot, 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 down, x. Unless you know what the shift state is at the start of a sequence of a multibyte character, you cannot parse a sequence like A, B, C, D, E, F, G, A, B, C, D, E, F, which could represent either 3 or 6 wide characters. The sequence AB or question mark X is invalid under encoding because a non-alphanumeric character appears in the upshift state. The sequence A or B is invalid because the last multibyte character ends prematurely. Multibyte characters might also use the state-independent encoding, which in the interpretation of multibyte characters do not depend on the previous multibyte characters, although you may have to look at the multibyte sequences from beginning to locate the beginning of a multibyte character section in the middle of a string. For example, the syntax of C's escape characters, section 2.7.5, represent a state-independent encoding for the type char. Since the backslash character, changes the interpretation of one or more of the following characters to form a single value of the type char. Encoding B. Another hypothetical encoding is state independent and uses a single special character in which to denote upside down triangle, to change the meaning of the following non-null character. The following sequences each contain multibyte characters under encoding B. ABC, upside down triangle. I'm gonna say up triangle. Or sorry, I'm gonna say down triangle, like as in which way it's pointing down. So down A, down B, down C, down, A space down BC. The sequence down is not valid under encoding B because it is a non-null character that's missing at the end. Standard C places some restrictions on multibyte characters. All characters from the standard character set must represent the encoding. In the initial shift state, all single byte characters must form a standard character set, retain their normal interpretation, and do not affect the shift state. A byte containing all zeros is taken to be the null character regardless of the shift state. No multibyte character can use a byte containing all zeros as its second or subsequent character. Together, these rules ensure that multibyte sequences can be processed as normal strings, e.g. they will not contain embedded null characters, and a C string without special multibyte codes will have the expected interpretation as a multibyte sequence. Source and execution of multibyte characters. Multibyte characters appear in comments, identifiers, and preprocessor header names, string constants, and characters constants. Each comment, identifier, header name, string constant, or character constant must begin and end with the initial shift state and must consist of a valid sequence of multibyte characters. Multibyte characters in physical representation of the source are recognized and translated into the source character set before any lexical analysis, pre-processing, or even splicing of communication lines. Example: a Japanese text including a program might allow Japanese characters to be written in a string constants and comments. If the text were written as a byte stream file, the Japanese characters would be translated to multibyte sequences, which would be acceptable to and, in the case of string constants, understood by standard C implementations. During pre-processing, characters appear in string and character constants are translated in the execution character set before they are interpreted by multibyte sequences. Therefore, escape sequences, section 2.7.5, can be used in forming multibyte characters. Comments are removed from a program before this stage, so escape sequences in multibyte comments will not be meaningful. Example: if the source and execution character are the same, and if A has a value of 141 subscript 8 in the execution character set, then the string constant quote down AA contains the same two multibyte characters as down \141 encoding B. References: character constant 2.4.3, comments 2.2, multibyte conversion facilities 11.7, 11.8, string constants 2.7.4, wchar_t 11.1, weof 11.1, wide character 2.7.3, wide string 2.7.4, wint_t 11.1. Holy shit, that was a stretch. I apologize for ignoring any and all comments. I spent most of the day writing programs to simulate drums and hats to make an audio file. Do you have any idea how I can find the pitch at a given point? Because I don't know how. So if I recall correctly, A3 has a reference pitch of 440 hertz, and then every subsequent pitch up or down from it is a division of 2 or doubling of 2. So for instance, A3 is 440, A2 is 220, A1 is 110, A0 would be like, what would 110 be translated to? That'd be like 55 hertz, respectively. And then inversely, A4 would be like 880, and then whatever one after that, because I can't do, 88 times 2, because brain's small. But yeah, that's how the rough thing translates for your little thingamajiggy. \n, \t, ... nobody \b. Nobody does the \r either. I'm gonna head to bed. See ya. Oodles. Have fun. Sorry for being late getting to your message, but there's not a ton I can do about that because I'm trying to read the chapters in chunks, so I apologize, but alas, this is how we suffer. Oh my god. Okay. Rolling forward. So we made it to comments. Holy crap. We made it to 2.2. Give it up for the boy. Alright, there are two ways to write a comment in standard C. Traditionally, the comment begins with an occurrence of two characters, / asterisk, and ends with the first subsequent occurrence of the two characters, asterisk, /. Comments may contain any number of characters and are always treated as whitespace. Beginning with C99, a comment also begins with the characters // and extends up to, but not include, the next line break. It is possible, but unlikely, that this change could break an older C program. It is left as an exercise to determine how this might happen. Comments are not recognized inside string or character constants, or within other comments. The contents of comments are not examined by the C implementation except to recognize and pass over multibyte characters and line breaks. Example, the following programs contains 4 valid C comments. // program to compute the squares of, // the first 10 integers, hashtag include, left angle bracket, standard io.h, right angle bracket, void squares, define, arguments, left parenthesis, no arguments in comments, right parenthesis, left squirrely bracket into I, semicolon, opening comment, loop from 1 to 10, printing out from the squares, closing comment for left parenthesis, I equals 1, semicolon, I, left angled bracket equals 10, colon, I plus plus, closing parenthesis, print F, opening parenthesis, double quotation mark, %D, // squared, // is, %D \n, comma I times I, closing parenthesis, comma, right curly bracket. Comments are removed by the compiler before preprocessing, so preprocessor commands inside comments will not be recognized, and line breaks inside the comments do not terminate preprocessor commands. Example, the following 2 define comments had the same effect. Hashtag define 10 in quotation marks, opening parenthesis 2 times 5, or 2 asterisk 5, closing parenthesis, hashtag define 10, opening comment, 10 colon 1 greater than 9, closing comment, opening parenthesis 2 times 5, closing parenthesis. Standard C specifies that all comments are to be replaced by a single character for the purposes of further translation of the C program, but some older implementations do not insert any whitespace. This affects the behavior of the preprocessor and is discussed in section 3.3.9. A few non-standard C implementations implement nested comments in which the occurrence of opening comment inside a comment must be balanced by a subsequent closing comment tag. This implementation is not standard. The programmers do not depend on it for a program to be acceptable to both implementations of comments. No comment should contain the character sequence opening comment tag inside it, aka / asterisk. Example, to cause the compiler to ignore large parts of a C program, it is best to enclose parts to be removed with the preprocessor commands hashtag F0 code here, hashtag endif, rather than insert / asterisk before and / asterisk / after the text. This avoids having to worry about the / asterisk style comment in the enclosed source text. References hashtag F preprocessor command 3.5.1, preprocessor lexicon conventions 3.2, Whitespace 2.1. Holy crap. Okay. I will stop after this next page. The characters making up the C program are collected into a lexical tokens according to the rules represented by the rest of this chapter. There are 5 classes of tokens: operators, separators, identifier, keywords, and constants. The compiler always forms the longest tokens possible, and it collects the characters in a left to right order, even if the result does not make a valid C program. Adjacent tokens may be separated by whitespace characters or comments. To prevent any confusion, an identifier, keyword, integer constant, or floating point constant must always be separated from the following identifier, keyword, integer constant, or floating point constant. The preprocessor has a slightly different token conventions. In particular, the standard C preprocessor treats hashtag and hashtag tokens. They would be invalid in traditional C. Example. Character C token pair. For while. B is less than X. B comma less than comma X. B dash right angled bracket X. B comma dash right angle bracket comma X. B dash dash X. B comma dash dash comma X. B dash 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 X. B dash comma comma B comma dash dash comma dash comma X. In the fourth example, the subsequent character B dash dash X is invalid. See syntax. The tokenization of B comma dash comma X would be valid syntax, but the tokenization is not permitted. References. Comments 2.2, constants 2.7, identifiers 2.5, preprocessor tokens 3.2, keywords 2.6, token merging 3.3.9, whitespace characters 2.1. Oh my god. Operators and separators. The operator and separator punctuator tokens in C are listed in table 2-3. To assist programmers using I/O devices without certain US-English characters and alternative spellings, left angle bracket, percent, right angle bracket, left angle bracket, colon, right angle bracket, percent, and percent, colon are equivalent to the punctuators left curly bracket, right curly bracket, left square bracket, right square bracket, pound, pound, respectively, in addition to these respellings. The header file, ISO 646.h, defines macros that expand to certain operators. In traditional C, the compound assignment of operators were considered to be two separate tokens. The operator and the equal signs that can be separated by whitespace. In standard C, the operators are single tokens. Operators and separators. Simple operators, bang, percent, rise, ampersand, asterisk, dash, plus, and equals. Compound assignment operators, plus equals, minus equals, asterisk equals, / equals, percent equals, left angled bracket equals, right angled bracket equals, ampersand equals, rise equals, and vertical / equals. Other compound operators, dash right angle bracket, plus, minus, left angle bracket, right angle bracket, left angle bracket equals, right angle bracket equals, bang equals, ampersand, vertical / separator characters, left parenthesis, right parenthesis, left square bracket, right square bracket, left curly bracket, right curly bracket, comma, semicolon, colon, period. And maybe period, or I believe ellipses, depending on how that wishes to be read. Alternative token spellings. Left angle bracket, percent, space, percent, right angle bracket. Left angle bracket, colon, space, colon, right angle bracket. Percent, colon, space, no space there, sorry. Percent, colon, or percent, colon. And that is where we shall rest with this. 20 pages in. So, not quite 10%. We are what? Like, that would be like 5% of the way through the book, I think? Let me check. My brain has turned to mush after that. Because holy heck. Holy heckin' hand grenade. Let's see. 20 divided by 400. I think it's like closer to 500, but whatever. Yeah, we're at about 5%. Okay.
Okay, my brain is not that mushy. My brain has not become that squishy.
Okay.
Okay. Okay. Fuck. Okay. Fuck.
Okay. I'm going to turn this heater down because I'm basically melting right now. I am actually too hot. I was trying to put up with it, but holy crap. I'm gonna turn the heater down. I'm gonna like fan the door a few times because holy crap, it's hot. Actually, I'm gonna go to the bathroom too. Sorry.
It's still toasty in here. It is still roasty toasty. So many roasties. Oh my gosh. Oh my gosh, it's time for me death.
Okay. Well, alas, I have made it through roughly 20 pages. I would say that's actually relatively good timing. To the people watching right now, hello. Hopefully you don't mind a slight shift in perspective. I don't know what you want to say. But at this point, we are going to draw a small line. And what I'm going to do is I'm going to transition to a new thing. And that new thing is going to be the Godot first 3D project scene thing. Because I have not had much experience at all with Godot in 3D. And then after we do so, we will, jump over to, whatever you want to call it. We will jump over to, doing other fun things. So, here's the first 3D game that we'll be committing to. Let me drag the soundtrack and back in because Arc is fun like that. There we are. First 3D game. Okay. Are we going to suffer from here? The answer is yes, we are. Let's see. Okay, I don't care about OBS right now. What I want is I want to go over to here and I want to get rid of this project and I want to do a new project. So let's quit Godot. X out of here. And then what we will do is we will reopen Godot and we will do a new project, our first 3D project. Holy heckin' heck. Okay. Create, let's see, your underscore first underscore 3D underscore game. Let us browse for the right asset pack thing. Let's do a new folder. Your underscore first underscore 3D underscore game. Huzzah. Select current folder. Create and edit. Let us go, shall we? Whoops. There we are. Okay. Carrying forward. Is it time to start? Let's see how many we got. Okay, we got a few things. So let's see. Shake out the willies. Shake off the willies. And let us roll forward. Your first 3D game. This page is up to date for 4.3. If you find outdated information, please open an issue. Your first 3D game. In this step-by-step tutorial series, you will create your first complete 3D game with Godot. By the end of the series, you will have a simple yet finished project of your own, that like an animated GIF below. Or sorry, like the animated GIF below. The game wheel code here is similar to your first 2D game with a twist. You can now jump, and your goal is to squash the creeps. This way you will both recognize patterns you've learned in the previous tutorial and build upon them with new code features. You will learn, work with 3D coordinates and with a jumping mechanic, use kinematic bodies to move 3D characters and detect when and how they collide, use physics layers and a group to detect interactions with specific entities, code basic procedural gameplay by instancing monsters at regular time intervals, design a movement animation, and change its speed at runtime. I just realized I forgot to write down the timestamp. I apologize. I'm just going to say, like, roughly 18.xx code.2d. There we are. Carrying on. Carrying on and carrying further. Oh my god, you've moved on. You moved from one manual to another. I am going to scree. Yes, but now we're doing the Godot manual. Isn't it awesome? This is how you get knowledge in your brain. This is how your brain gets swollen. This is how you start looking like Jimmy Neutron. This is how you start looking like the chocolate brown ice cream cone, like soft serve. You know, the ones where you go like the freaking market, and it's like woo, and you have like a stack that's like crazy. You got a little curlicue at the top of your hair, little foop. Oh, I'm sorry, I forgot to read and more. This tutorial is for beginners who followed the complete Getting Started series. We'll start slow with detailed instructions and shorten them as we do simpler steps. If you're an experienced programmer, you can browse the complete demo source code here. Note, you can follow the series without having done the 2D one. However, if you're new to game development, we recommend that you start with the 2D. 3D game code is always more complex, and the 2D series will give you foundations to follow along more comfortably. We prepared some game assets so we can jump straight into the code. You can download them here, squash the creeps assets. I will do that very quickly. Let's just get the, let's just get that, and then we'll just go into WesTerm, the Wiz terminal. We'll go, Godot, and then we'll replace that with a 3D game. And then we'll do git clone, paste the link. Is this a Git repository? I believe it was. Let's open link a new tab. Maybe it didn't copy right. Maybe it copied the link weird. Let's try this again. What is it? It's Control U, yeah. Git clone. It's not valid as a Git repository. Yeah, it is. I guess we'll just do the, that one. Sure. Why not? You drank an energy drink before the stream, didn't you? Kind of. I drank one at like 4. I'm kind of at that half manic state where it's like I'm like awake, but I've also been up since like 5:30 for some ungodly reasons, so I'm now pushing 17 hours of awakeness. Kill me. Let's see. Show and Finder. Let's open a new tab. We'll go Control-Shift-G. Let's just jump to the Godot. No, Godot isn't coming up. There we are. Whoops. Okay, let's go to the end of that. Except for that, we'll go all the way back. Your first 3D underscore game / There we are. There we are. Whoop. Okay, that's gonna be slightly annoying with nesting, but alas, here we go. Let's do this. So we'll do drag that into here. And then we'll go back one, and then we'll drag you up a layer. Which I know will make Godot unhappy, but that's a risk I'm willing to take. Whoop, no, go back, please, go back, please, go back, please, go back, please, go back, please. If you could witness what I'm doing, you will understand. Let's go up a folder. Then we'll go into here, and then we'll go here. Then we'll go back. Okay, let's do this. Let's do... We'll rename it to glurp. And we'll drag the folder from here out. Whoops. There we are. We'll delete glurp. And then we'll reopen the Godot project because, yeah. So we're going to force quit that. Just a hard kill it. And then I'll have to relocate the thing-a-thing. Let's see. Look at this Godot graveyard. Godot test, Godot test. Do I not have that other one? Yeah. Can I not, like, locate you? Just remove missing, I guess. Remove all. Import. Let's do this. And we'll select this. And select current folder. Import and edit. There we are. Now we wait for this to disappear. There it is. Huzzah! Okay, so where are we going from here? My first 3D game. We will work on the... We will first work on a basic prototype for the player's movement. We will then add the monsters that will spawn randomly around the screen. After that, we'll implement the jump and squashing mechanic before refining the game and some nice animation. We'll wrap up with the score and the retry screen. Neat. Setting up the game area. If you have headphones on, brief warning, because I'm going to tap the mic real quickly for editing purposes. Okay. There was your warning. Setting up the game area. In this first part, we're going to set up the game area. First, let's get started by importing the start assets and setting up the game scene. We prepared a Godot project and the 3D node modules and sounds we'll use for this tutorial linked in the page. If you haven't done so, you can download them from the archive here. Once downloaded, extract the .zip on your computer, open the Godot Project Manager, and click the Import button. In the Import pop-up, enter the full path to the freshly created directory squashed _the_creeps_start. You can click the Browse button at the top right of the file browser to navigate to the project.godot and the file folder contains. Click the Import. Click Import and Edit to open the project and the editor. A window will open... a window notifying you the project was generated by an older Godot version may appear. Click the Convert Full Project to convert the project to your current Godot version. The Start project contains an icon and two folders, art / and fonts /. There you'll find the art assets and music we'll use in the game. There are two 3D models, player.glb and mob.glb. Some materials that belong to these models and music track. Setting up the playable area. We're going to create our main scene with a plain node as a root, and in the scene dock, click the Add Child Node button represented by a plus icon. In the top left, double-click on node and name the node main. An alternative method to rename the node is to right-click on a node and choose rename or F2. Alternatively, add a node to the scene. You can press Control-A, Command-A on macOS. I'm going to keep reading, and I'll do the tutorial after, so we can have a little bit of a break. Setting up the playable area. Oh, did that already. Saving the scene as main.tcsn by pressing Control-S or Command-S on macOS. We'll start by adding a floor that'll prevent the characters from falling. To create a static collider on the floor, walls, or ceilings, you can use static body 3D nodes that require collision shape 3D child nodes to define a collision area. With the main node selected, add a static body 3D node and then a collision shape 3D. Rename the static body 3D ground. Your tree should look like this. Main as a child of main ground, and then as a child of ground collision shape with little warning. A warning sign next to the collision shape 3D appears because you haven't defined its shape. If you click on the icon, it appears and gives you more information. To create a shape, select the collision shape 3D node, head to the inspector, and click on the empty field next to the shape property. You can create a new box shape 3D. The box shape is perfect for flat ground and walls. Its thickness makes it reliable to block even fast-moving objects. A box's wireframe appears in the viewport with 3 orange dots. You can click and drag on these nodes to edit shapes extents interactively. We can also precisely set the size of the inspector. Click on the box shape 3D to expand the resource. It's set its size to 60 on the x-axis, 2 for the y, and 60 for the z. Collision shapes are invisible. We need to add a visual floor to go along with it. Set the ground node and add a mesh instance 3D as its child. In the inspector, click on the field next to the mesh and create a box mesh resource to a visible box. Once again, it's too small by default. Click the box icon to expand the resource and set its size to 60, 2, and 60, XYZ respectively. You should see a wide gray slab that covers the ground and blue and red axes in the viewport. We're going to move the ground down so that we can see the floor grid. To do this, the grid snapping feature can be used. Grid snapping can be activated 2 ways in the 3D editor. First, by pressing the U-snap button or the Y key. The second is by selecting the node and dragging the handle in the gizmo, and then holding Control while clicking to enable snapping as Control is held. Start by setting snapping with your preferred method, then move the ground using the Y-axis green arrow on the gizmo. Note, you can't see the 3D object manipulator on the image above. Ensure that select mode is active. If you can't, then ensure select mode is active in the toolbar window. Move the ground down 1 meter in order to have a visible editor ground. A label in the bottom left corner of the viewport tells you how much you've translated the note. Example being translating, left parentheses 0, -1, 0, right parenthesis. Note, moving the ground node down moves both children along with it. Ensure you move the ground node, not the mesh instance 3D or the collision shape 3D. Ultimately, ground's transform position .y should be -1. Let's add a directional light so our scene is in all gray. Select the main node and add a child node, directional light 3D. We will move and rotate the directional light 3D node, move it up by clicking and dragging the manipulator's green arrow, and click and drag on the red arc to rotate it on the x-axis until the ground is lit. In the inspector, turn on shadow enabled by clicking the checkbox. At this point, your project should look like this. That's our starting point. In the next part, we will work on the player's scene and base movement.
Too much reading. Holy shit.
Okay, so now we will take a small break and we will make our own instance. So we'll just do another node. We'll just make it node. We'll add a, no, it was a collision shape, wasn't it? Collision shape 3D. We want a mesh instance 3D. And then, isn't that what we wanted? I'm tripping. I just read it. Let's see. What is the ground supposed to be? Ground is supposed to be a... Ground is the only thing that's bothering me. Static body 3D. Static body 3D. We'll make this the child thing here. I'll make you the children here. And then we will simply enable the shape as a new box shape. We'll do the transform. We'll say scale will be 60 unlock the transform so it isn't universal. 2 and 60. I realized I did the wrong axis. Gosh darn it. There we are. 60. Unlock 260. There we are. We will reset the transform to 1. So that way it's in line with the thingamajigam. And the static body 3D is saying, okay. What scale did it say to adjust? Oh, it says to adjust the size, not the scale. Okay, I see. So how do I adjust the size? Where is that? Collision. That's access lock. Physics material. Filter properties by size. I'm not seeing a size. We'll rename this to ground. Collision shape 3D. Okay. Do you not do anything with the ground then? I guess the shape is implicit. Let's see. I'm not seeing a size assignment anywhere. That is odd. Is it here, perhaps? No. Can I set one here? If I just say a new box mesh? Okay, there's that. So I can do 60 to... Whoops. 60. There's that. Is it because I perhaps selected the wrong property? There it is. It's in the drop down. 62, 60. There we are. Okay. And then we now need to add a heckin' light source 3D. Did they want us? I know they wanted a specific light. What was the specific light they wanted? They wanted a... I believe it was a directional light. Let's see. Yeah, directional light 3D. Let's move you up. Click on that until the ground is lit. I like a little bit of dynamicism to my lighting. And then from here, there's one other thing I was missing, I believe. Okay, so the mesh does not need to be a child of the collision. Those are separate. We'll rename node to main. I'm gonna name this with a capital because why not? Ground, directional light. Yep. And I think that was effectively it outside of moving it down. That does seem to be correct. Let's see. There we are. That seems good to me. It's a little hard to see, so I think I'll adjust that directional light. There we are. Yeah, I think that's okay. We'll say that as main.tcsn. I don't see why I would say that anywhere else. Zizzity za. Okay. What? That's running a little chunky now. Oh, I see. It's because it was a background app for a second there, so it wasn't loading properly. Like it didn't have the proper resources allocated to it. Let's see. Player scene and input actions. New section. Player scene and input actions. In the next two lessons, we will design the player scene, register custom input actions, and code the player movement. By the end, you will have a playable character that moves in 8 directions. Create a new scene by going to the script menu in the top left corner by clicking New Scene. Create a character body 3D node as the root. Name the character body 3D to player Character bodies are complementary to the area and rigid bodies used in the 2D game tutorial. Like rigid bodies, they can move and collide with the environment, but instead of being controlled by a physics engine, you dictate the movement. You'll see how we use these. You'll see how we use the node's unique features when we code the jump and squash mechanics. To learn more about different physics node types, see the physics introduction. I will definitely refer to that later. For now, we're going to create a basic rig for our character's 3D model. This will allow us to rotate the model via code when it plays an animation. Add a node 3D as a child of player and name it pivot. Then in the file system doc, expand the art folder by double-clicking it and drag and drop the player.glb into pivot. This should instantiate the model as a child of pivot. You can rename it to character. Note, the .glb file contains 3D scene data based on open source GLTF 2.0 specification. They're a modern and powerful alternative to the proprietary format like FBX, which Godot also supports. To produce these files, we designed the model in Blender 3D and exported it to GLTF. As with all kinds of physics nodes, we need a collision shape for our character to collide with the environment. Select the player node again, and add a child collision shape 3D in the inspector to shape properly. On the shape property, add a new sphere shape 3D. The new sphere's wireframe should appear below the character. It will be the shape the physics engine used to collide with the environment, so we want to make it a better fit to the 3D model. Make it larger by dragging the orange dot in the viewport. My sphere has a radius of about 0.8 meters. Then move the collision shape up so its bottom is roughly in lines up with the grid. To make moving the player easier, you can toggle the model's visibility by clicking on the eye icon next to the character or player or the pivot nodes. Save the scene as player.tcsn. With the nodes ready, we can almost get coding, but first we need to find some input actions. Creating input actions. To move the character, we'll listen to the player's input, like pressing arrow keys in Godot. We could write all the key bindings in code. While we could write all the key bindings in code, there's a powerful system that allows you to assign a label to a set of key bindings. This simplifies our scripts and makes them more readable. This system is the input map. To access its editor, head to the project menu and select project settings. At the top, there are multiple tabs. Click on input map. This allows you to add new actions to the top. They are your labels. In the bottom part, you can add keys. You can bind keys to these actions. Godot projects come with some predefined actors designed for the user interface. See the above screenshot. These actions become visible if you enter the show built-in actions toggle. We could use these here, but instead we're defining our own support gamepads. Leave show built-in actions disabled. We're going to name our actions move left, move right, move forward, move back, and jump. To add an action, it is named in the bar and then press enter. Create the following 5 actions: move left, move right, move forward, move back, jump. Add a keybind to the action, click the plus to its right. Do this for move left, press the left arrow key, and then click OK. Also bind A into the section move left. Now let's add support for the gamepad's left joystick. Click the plus again, but this time in manual selection, joypad axes. Select the negative x-axis of the joystick. Leave the other values default and press OK. Note, if you want controllers to have different input actions, you should use device option in additional options. Device 0 responds to the first plugged-in gamepad, device 1 responds to the second plugged-in gamepad, and so on. Do the same for other input actions. For example, bind the right arrow D and the left joystick's positive axis to move_right. After bind all keys, the interface should look like this. The final action is to set up is the jump action. Bind the spacebar and the gamepad's A button. Your jump action should look like this. That's all the actions we need for this game. You can move this menu to label any groups of keys and buttons in your projects. In the next part, we'll code the player's movement. We'll code and test the player's movement. Hey. Okay, so let's begin with the thing. So we'll create a new scene, 3D scene, but I want to replace the node. Change type to player. Player. I believe it was a player body, wasn't it? Body. Character body 3D. And then next we want it to be, I'm just going to look at the overview to cheat a little bit. Because we want the character body, and then we want node 3D, which will be pivot. Node 3D, which will rename to pivot. Yes. And then we'll go into here. It's odd that it's not detecting any folders in here. It should see some. Let's see. Icon, art. And I believe it was player.glb, which we should drag into here. There we are. Dragging that in. This is player. We'll create a new folder, name it player underscore stuff. And we'll save it as player. And then here we need to add a collision shape 3D. Collision shape 3D. They said select a sphere. Move it out. And then move the whole player up until the sphere roughly touches the base. So let's do that real quickly. Oh, let's actually select that and we'll make you a little bit smaller. There we go. Okay, so there's the player. Okay, I have no idea what happened here. So that's awesome. There we are. Whoa, what happened with you? I wonder if there's a hotkey to view select. That'd be awesome. Could I do something cheeky, like just period on the numpad? F for focus. F is for focus. Got it. Awesome and magical. Okay, so let's save that again real quickly. And then now that we are here, we will then jump into the thing here. Yeah, we still got the inputs. I just want to make sure everything's right. So it was player pivot character. So let's see. Player pivot character. Character. What do I feel like I'm spelling that wrong? Dyslexia's kicking in. Nope, that looks right. Okay, cool. Alright, so after we've done the character, we'll then carry on, and then we will do the input actions. So let's see, it should be project or something. Project settings. Input map. I want to skip the controller stuff because I'm not that concerned about it. So we'll do move underscore left, move underscore right. Whoop, that's not the right character. Move underscore right. Move underscore up. Move underscore down. Yump. Okay, now that we have that, we just need to go plus left. Okay, plus right. Okay. Plus up. Okay. Plus down. Okay. Jump. Cool. Okay. Close. Save. Control Shift S. Or not S. Is there not a save all? I thought there would have been a save all. Save all scenes. Okay, that's just mash all the buttons and then S. Okay. let's see. So I believe I have done it outside of the other mappings, but being realistic, because it's only ever going to be on my scene, then I think that's going to be basically it from Moy. So let's hop into the next and then see what we get from there. Let's see. Move the player with code. It's time to code. We're going to use input actions we created in the last part to move the character. Note, for this project, we will follow the Godot naming conventions. GD script, classes, nodes use Pascal case, variables and functions use snake case. And constants use all caps. See GD script style guide. C#, we are going to ignore that because C# is not valid. Right-click the player node and select attach script to add a new script in it. In the pop-up, set the template to empty before pressing the create button. We set it to empty because we want to write our own code for player movement. Let's start by adding the class's properties. We're going to define movement speed, a fall acceleration representing gravity, and a velocity we'll use to move the character. In GD script, extends character body 3D. At export, var speed equals 14. Export var fall acceleration equals 75. Var target underscore velocity, I don't know why I underscored velocity, all of it's underscore velocity, equals vector 3.0. These are common properties for a moving body. The target velocity is a vector, 3D vector, combining speed with a direction. Here we define it as a property because we want to update and reuse its value across frames. The values are quite different from 2D code because the distances are in meters. While in 2D, 1,000 units pixels may only correspond to half your screen's width. In 3D, it's a kilometer. Yes. Let's code the movement. We'll start by calculating the input direction vector by using the global input in physics or underscore physics underscore process. GD script func underscore physics underscore process left parenthesis delta right parenthesis colon var direction equals vector 3.0. We create a local variable to store the input direction. That last one was a comment. Comment, we check for each movement input and update the direction accordingly. If input dot is action pressed, move right, or left parenthesis, move right, right parenthesis, colon, direction dot x plus equals 1. If input dot is action pressed, left parenthesis, move left, right parenthesis, colon, direction dot x minus equals 1. If input dot is underscore action underscore pressed, left parenthesis, move back, right, colon. Notice how we are working with the vectors x and z axes. Comment, in 3D, the xz plane is the ground plane. Direction dot z plus equals 1. If input dot is action pressed, left parenthesis, move forward, right parenthesis, colon, direction dot z minus equals 1. Here we're going to make all calculations using the underscore physics underscore process virtual function like underscore process. It allows you to update the node every frame, but is designed specifically for physics related code like moving a kinematic or rigid body. Learn more about the difference between underscore process and underscore physics process. See idle and physics processing. I will do that in a new tab. We start by initializing a direction variable to vector 3.0. Then we check if the player is pressing one or more of the move.any inputs to see if their vectors x and z components accordingly. Sorry, to update the vectors x and z components accordingly. These correspond to the ground's plane axes. The 4 conditions give us 8 possibilities and 8 possible directions. In case the player presses, say, both W and D simultaneously, the vector will have a length of about 1.4. But if they press a single key, it will have a length of 1. We want the vector's length to be constant and not move faster diagonally. To do so, we can call its normalized method. Comment func underscore physics underscore process left parenthesis delta right parenthesis colon more comments and code examples. If direction is not equal, aka bang equals vector 3.0 colon direction equals direction dot normalized left closing left parenthesis right parenthesis. Comment setting the basics property setting the basics property will affect the rotation of the node. $pivot dot basics equals basics dot looking underscore at left parenthesis direction right parenthesis. Here we only normalize the vector if the direction has a length greater than 0, which means that the player is pressing a direction key. We compute the direction. The $pivot is looking by creating a basics that looks in the direction. I'm going to open up the directions for later, or the basics for later. We then update the velocity. We have to calculate the ground's velocity and the fall separately. Be sure to go back one tab so the lines inside the underscore physics underscore process function, but also outside the condition just wrote above. If function underscore physics underscore process left parenthesis delta right parenthesis colon if direction not equal vector 3.0 colon code comment ground velocity target underscore velocity dot x equals direction dot x times speed target underscore velocity dot z equals direction dot z times speed comment vertical velocity if not is underscore on underscore floor left right parenthesis colon comment if in the air fall towards the floor literally gravity target dot velocity dot y is equal to target underscore velocity dot y minus left parenthesis fall underscore acceleration times delta right parenthesis moving the character, comment moving the character. Velocity is equal to target velocity. Move underscore and underscore slide left right parenthesis. The character body 3D dot is underscore on underscore floor left right parenthesis. Function returns 2 if the body collide with the floor in this frame. That's why we can apply gravity to the player when it's only in the air. For the vertical velocity, we subtract the fall acceleration multiplied by the delta time every frame. This line of code will cause our character to fall in every frame, as long as it is not on or colliding with the floor. The physics engine can only detect interactions with walls, the floor, or other bodies during a given frame. Movement and collisions happen. If movement and collisions happen. We will use this property later to code the jump. On the last line, we call character body 3D.move underscore and underscore slide, which is a powerful method of the character body 3D class that allows you to move the character smoothly. If it hits the wall midway through motion, the engine will try to smooth it out for you. It uses the velocity value to the character body 3D. Native to the character body 3D. And that's all the code you need to move the character on the floor. Here's the complete player.gd code for reference. Extends character body 3D. Comment how fast the player moves in meters per second. At export var speed equals 14. Comment the downward acceleration when in air in meters per second squared. At export var fall underscore acceleration equals 75. Var target underscore velocity equals vector 3.0. Func underscore physics underscore process left parenthesis delta right parenthesis colon var direction equals vector 3.0. If input dot is underscore action underscore pressed left parenthesis double quote move underscore right double quote right parenthesis comma direction dot x plus equals 1. If input dot is action dot is underscore action underscore press, left parenthesis, double quote, move underscore left, double quote, right parenthesis, comma, direction dot x minus equals 1. If input dot is underscore action underscore press, left parenthesis, double quote, move underscore back, double quote, right, colon, direction dot z plus equals 1. If input dot is underscore action underscore press, left parenthesis, double quote, move underscore forward, double quote, right parenthesis, colon, direction dot z minus equals 1. If direction not equal vector 3 dot 0, colon, direction equals direction dot normalized, left right parenthesis, $ pivot dot basis equals basis dot looking underscore at, left parenthesis, direction, right parenthesis. Comment, ground velocity. Target underscore velocity dot x is equal to direction dot x dot times speed. Target underscore velocity dot x is equal to direction dot z dot times speed. Comment, vertical velocity. If if not is underscore on underscore floor, left right parenthesis, comma, or colon, comment, if in the air, fall towards the floor, literally gravity. Target underscore velocity dot y equals target underscore velocity dot y minus left parenthesis fall underscore acceleration times delta right parenthesis comment moving the character. Velocity is equal to velocity equal target underscore velocity move underscore and underscore slide left right parenthesis. Testing our player's movement. We're going to put our player in the main scene to test it. To do so, we need to instantiate the player and then add a camera. Unlike in 2D, in 3D, you won't see anything if your viewport doesn't have a camera pointing at something. Save your player scene and open the main scene. You can click on the main tab at the top of the editor to do so. If you close the scene before, head to the file system dock and double-click main.tsn to reopen it. To instantiate the player, right-click on the main node and click Instantiate Child Scene. In the pop-up, double-click player.tsn and the character should appear in the center of the viewport. Add in the camera. Let's add a camera next, like we did with our player pivot. We're going to create a basic rig, right-click the main node again, and select Add Child Node. Create a new marker 3D and name it Camera Pivot. Select Camera Pivot and add a child node, Camera 3D, to it. Your scene tree should look something similar to this. Main, childed to main ground, childed to ground collision shape 3D, childed to ground mesh instance 3D, childed to main directional light 3D, childed to main player, childed to main camera pivot, childed to camera pivot camera 3D. Notice in the preview checkbox that appears in the top left of the 3D view when you have the camera selected, you can now click it to preview the in-game projection. We're going to use the pivot to rotate the camera as if it was on a crane. Let's first split the 3D view and be able to freely navigate the scene and to see what happens with the camera axes. In the toolbar above the viewport, click on the view, then two viewports. You can also click Control+2, Command +2 on macOS. In the bottom view, select your camera 3D and turn it on turn on camera preview by clicking the checkbox. In the top view, be sure your camera 3D is selected and move the camera about 19 units on the Z-axis and drag the blue arrow as a hint. Here's where the magic happens. Select the camera pivot and rotate it -45 degrees around the X-axis using the red circle. You'll see the camera move as if it was attached to the camera crane. You can run the scene by pressing F6 and press the arrow keys to move the character. We can see some empty space around the character due to the perspective projection. In this game, we're going to use an orthographic projection instead to better frame the gameplay area and make sure it's easier for the player to read distances. the scene camera again in the inspector. Sorry, select the camera again and in the inspector. Set the projection to orthogonal and the size to 19. The character should now look flatter and the ground should fill the background. Note: when using an orthogonal camera in Godot 4, directional shadow quality is independent on the camera's far value. The higher the far value, the farther away the camera will be able to see. However, higher far values also decreases shadow quality, as the shadow rendering has to cover a greater distance. If directional shadows look too blurry after switching to an orthogonal camera, decrease the camera's far property to a lower value, such as 100. Don't decrease this far property too much, or objects in the distance will start disappearing. Test your scene. You should be able to move in all 8 directions, not glitch to the floor. Ultimately, we have both player movement in and the view in place. Next, we'll work on the monsters. Okay, that was a lot. So let's get going. Let's get going with the going. So what I want to do first is I'm going to be extra lazy, honestly, and just copy the script. Because I am currently starting to burn that midnight oil, as they say. So let me rename pivot to capital PIVOT. And then under player, we'll add a new script. Player.gd. I'm just going to move that over there. And then in player stuff, we're just going to paste that. Save that. Hope that it works. Because heckin' I am not hyped to do all that. Then we will add a player.tcsn to main. And then we will add under main a camera. Camera. Wasn't it pivot? PIVOT? What was the node they added there? That's the one thing that's catching me right now. Let's see. So they want us to add a... let's see. Add a child node, create a new marker 3D. Marker, whoops. Marker 3D. Name it to camera underscore pivot. I'm gonna rename that camera underscore pivot, and then a new camera. And then they were saying in the scene, move the thing up about 19 units. Whoops, I should not have done it that way. Should have done it this way. Move it up. On the Y, it should be about 19. And then Command 2 to open up the viewport. And then the bottom one, select the camera preview. Where's the camera preview? Cinematic preview? Yes. And then with the camera selected, can I rotate you? I can. Suffer and succotage. Okay, and then from there I want to select the camera and turn on orthogonal. What's futism? Ah, that's up very far out. There we are. And then we want the size to be... I believe it's the size at least. Yeah, something like that. And then after we have the size adjusted, let's very quickly see if we can do anything. So we're in main, so let's select main. Ah, there's some error with up and down. Let us begin to debug the error for up and down. Because holy crap. Let's see. Player.gd, move. I see, because I made it move down and move up. That's something I would have done. Move down, move up. Let's try again. Yep, there we are. Okay, so we now have that. We now have the little blender doober. So, with that being said, we will pause it here. Thank you everybody so much for watching. I hope you enjoyed 2 manual readings. I'll wish you all a good night, and I'll catch you some other time. Bye-bye. Oodly toot.